Hello, my dear JEE warriors. Welcome to the 100 questions with the concept series, where you are going to revise the entire of physics, the entire of chemistry tomorrow, and mathematics in the next 3 days, where you are going to see all the amazing questions at one single place. And this is going to be obviously a marathon session. And when we do these 100 questions, obviously these questions are very crucial, very nice. They are handpicked and they test a lot of concepts. They will help you, make you realize certain things. They will make you tell that, okay, listen, you have forgotten this or you have to revise this. And it will push you to complete as much as possible and just to build up your concepts. So quickly join in for the most amazing series, the 100 question concept series for your April attempt, the second attempt of JEE Mains 2025. And welcome aboard live on the channel. Thank you so much, guys. I hope you guys are doing extremely well. And please smash that like button down there. Yeah, it's very important. Good morning, Joseph, Ayanshu, Gautam, all the lovely, amazing, enthusiastic warriors. And do not forget that we have kept the test series link, everything in the description box. So please check it out. Okay. And by the way, those of you who are in Bangalore, we are going to come and meet you next Sunday. So there is a link for it. Please fill that up. It's an amazing event where all of our team members will be there in the Bangalore Center in JP Nagar. So please fill up this particular link and select your grade. You can also inform your juniors and which kind of examination you are preparing for. Since this is a meetup in Karnataka, so obviously many students might be also writing the KCT exam. So if you're preparing for that, please let us know. And in this particular event, we are going to conduct a proper workshop for JEE separate, NEET separate, and for KCT separate. So this is a proper marks booster workshop. It's not just, hey, hi, how are you doing? No. That's not what is going to happen. It's a marks booster workshop in the JP Nagar Center in Bangalore. Okay. All the details will be sent to you and we'll keep on updating regarding the same. All right. So let's begin with the class. And thank you for smashing that like button down there. This will be a marathon, obviously. Cool. Okay. So let's begin, guys. And first, I'm going to pick out some questions from units, dimensions, and applications of dimension analysis. A lot of weightage was there in the January attempt, which tells you that you cannot obviously ignore it. So these are the kind of questions which come, and the concept behind this is the principle of homogeneity. The principle of homogeneity in dimensions. See, what happens is whenever you have dimension based questions, always remember the dimensions on the left hand side and the dimensions on the right hand side, they have to match each other. If they do not match, then it is 100% incorrect. Also, remember that if there is a particular physical quantity 1 and there is another physical quantity 2, then you can add them or subtract them only if they have the same dimensions. If they have the same dimensions, but you cannot do any kind of addition or subtraction with any other physical quantity, let's say number 3, if they are of different dimensions. This is not allowed. Okay, this is not allowed. They are of different dimensions. This is definitely not allowed. But multiplication and division is allowed. So I can have physical quantity 1 by physical quantity number 2, and I can also multiply it with physical quantity number 3. They can all have different dimensions, and that is definitely allowed. This is allowed. This is allowed. Okay, keep these things in mind. Multiplication and division of different quantities of different dimensions is allowed. Same dimensions have to be either added or subtracted. Different dimensions can't be added or subtracted. The last thing over here is whenever you have trigonometric ratios, etc., like sine or cos, or let's say log, or let's say exponent, meaning something, all whatever is there inside over here has to be completely dimensionless. Everything over here has to be completely dimensionless. So this is dimensionless. In all this trigonometric, logarithmic, exponential functions, whatever is there inside, should be dimensionless. Okay, this is what is generally needed. Shall we do a question, guys? Fire up the chat box quickly. Hi Bala, welcome aboard. All right, very good, Suchivama. CUET is definitely a good exam. Oh, oops, sorry. Let's see the question now. An expression for energy density is given by blah blah blah, where alpha, beta are constants. X is basically the displacement, K is Boltzmann constant, T is not time, it is temperature. Mind it, the dimensions of beta will be exactly what? Okay, what will be the dimensions of beta? Now, in order to find the dimension of beta, we cannot do it individually because I need to know what is alpha and I also need to know what is the dimension of u. Without that, I will not be able to proceed. That is absolutely clear. But one thing is there, to find the dimension of alpha, look at the brackets inside the sign. That entire term should be dimensionless. So if you look at whatever is there inside, which is alpha, whatever is there inside of alpha, and then you have x, and then you have basically Boltzmann constant into temperature. This should be completely a dimensionless quantity, whatever is there inside. Is that absolutely clear, my dear students? Yep. Okay. Now, what is this kT? If you remember from kinetic theory of gases, half kT, 3 by 2 kT, 5 by 2 kT, these were the energy values of a molecule with certain degrees of freedom. So, kT basically corresponds to the energy of any molecule. So, in general, I would say dimensionally speaking, it is the dimensions or it is having the same units as of energy. So, why not write this as alpha into basically x dimensions, the whole thing divided by just the dimensions of energy, just the dimensions of energy is basically dimensionless. But meanwhile, I will also convert x over here. X is also nothing but the having the same dimensions of length over here. This is going to be dimensionless. Therefore, alpha's dimensions will be the dimension of energy, which is there over here, the whole thing divided by the dimension of length. The whole thing divided by the dimension of length. Length goes below, energy goes on top. Okay, so I found out alpha. Before going ahead, I know sine as a whole is a dimensionless number. Alpha by beta's dimensions will be the dimension of u. So the dimension of u will be the same as the dimension of alpha by beta because sine has no dimensions. The value of sine is a completely dimensionless quantity. Now, what is this u? It is given as energy density. What is the meaning of energy's density? It is how much energy is there per unit volume. So therefore, this should be nothing but the amount of energy which is there divided by the amount of volume which you are talking about, and that will have dimension of alpha on the top and the dimension of beta over here. The dimension of beta over here. What is alpha? I just got it over here. Alpha is nothing but the dimension of energy, the dimension of energy, the whole thing divided by the dimension of length. This was anyways dimensionless quantity. Is that right? Do you see energy gets cancelled out? Do you see energy get cancelled out? Volume is nothing but the cube of the length, and this is 1 by beta, of course, and this is 1 by L is remaining over here. One length will get cancelled, and I'm just left with L raised to 2 is nothing but 1 by your beta. 1 by your beta. So therefore, the dimension of beta will be nothing but the dimension of the square of the length. Dimension of the square of the length, which is nothing but your option number D. M raised to 0, L raised to 2, T raised to 0. Is that understood, my dear students? How we have basically gone from inside to outside. And the best part was, somehow I thought that maybe let me not write the dimensions of energy as m raised to 1, L raised to 2, T raised to minus 2. Can you guess why I did not do that? You'll be like, sir, maybe you thought energy will get cancelled. But who in the you know exams mindset would be able to think that somewhere down the line it will get cancelled? So for that, you need to keep your eyes open. When you read the question itself, you should see, oh, energy density, or something related to energy is already there. KT is also energy, maybe energy, examiner would have thought about the students. You should give that benefit of the doubt. If it doesn't get cancelled, okay. Later on, I would have put the dimensions of energy, but don't initially substitute the dimensions of energy. Maybe it got cancelled, and exactly happened that way. Is that okay? Everybody with me? Understood? Clear? Can we go ahead to the next question? Yep. So moving on to the next question, guys. Given below are the two statements. One is labeled assertion, other is labeled reason. Assertion says time period of a liquid drop depends on the surface tension, density, and the radius of the drop. And time period is some constant which is dimensionless, root rho r cube by s raised to 3 by 2. Okay. Using dimensional analysis, we get RHS having different dimensions that of time period. See, one thing is clear. This is actually going to be easy because it is assertion reason. Think about it. Think about it. This statement is provoking us. RHS and LHS, they have different dimensions. Meaning, most likely, this might not have the dimensions of, most likely, I'm guessing, might not have the dimensions of time period. So, basically, again, using principle of homogeneity, which I taught you. So, let's figure out what the dimensions could be. So, starting off with whatever the quantities are there, on the right hand side, our right hand side is k root of rho r cube, the whole thing divided by s raised to 3 by 2, s raised to 3 by 2. Okay, so what is the dimensions of right hand side? Well, k is nothing but a dimensionless number. Dimension of density raised to half, dimension of radius raised to 3 by 2 because it is under the root. Then the whole thing divided by the dimension of surface tension whole raised to 3 by 2 by 2, 3 by 2 by 2, correct? Because that by 2 is because of that root. So let's see what it will be. Dimension of density, it is mass per unit length, per unit volume. So m raised to 1, L raised to minus 3 it will be because it is volume. So whole raised to basically half. Radius is nothing but measured in terms of length. So length raised to 3 by 2 it is. The whole thing divided by S over here. S over here. This is surface tension, which is force per unit length. Force per unit length. So force dimension is m raised to 1, L raised to 1, T raised to minus 2. The whole thing divided by length. Okay, the whole thing will be raised to. This is force, this is length. Remember that, okay? Because surface tension is nothing but the force per unit length. That is what surface tension is. Force per unit length. The whole thing raised to, what is it? 3 by 2 by 2, which is 3 by 4. Now I will tell you, don't have to solve the problem completely because you are not going to get any marks for the steps, nor do you have to find what is the exact dimension on the right hand side. Just concentrate on the mass term. Just concentrate on the mass term, guys. Just look at the term which is there of the mass. That will be enough to see whether you were seeing what is the power of m, and from that you can confirm whether LHS is equal to RHS or not. So on the top you have m raised to half. At the bottom you have m raised to 3 by 4. M raised to 3 by 4. So if you take it on the top, it will become m raised to half minus 3 by 4, which is nothing but m raised to. So this will be nothing but what is it? Minus 1 by 4, I believe. 4 minus 2 minus 3 is nothing but minus 1. So minus 1 by 4. Now, if you have the power of mass as minus 1 by 4, 100% it will never match the dimensions of LHS. So here what I will write, but on the left hand side, the dimensions should be mass raised to 0, something will be there, but actually it is time, right? So L raised to 0, time raised to 1. So if the power on the LHS of mass should be 0, how is it on the RHS it is minus 1 by 4? So this clearly tells that the principle of homogeneity is not obeyed. So the dimensions are not matching on the left hand side on RHS. Hence, the answer should be A is false, but R is true. So this formula can never ever be correct. But this particular statement, it is 100% explaining it because it is having different dimensions than that of the time period. The dimension analysis says RHS is having different dimensions as that of the time period. This is exactly what we got. LHS and RHS dimensions are not matching. Any one is not matching, you don't have to check others. Obviously, length and time, even if they match, doesn't matter. Every single dimension of every single physical quantity has to match. Is that okay, everyone? Yeah, it's going to be a long session, of course. It's going to be a long session. Okay. Is this absolutely clear? Did you love this question, guys? So the best part was because it was statement based, you didn't have to really find out the complete dimensions on the right hand side. Let's do some questions on errors and vectors, of course. Let's do some questions on errors and vectors, of course, right? So let's start with some questions, guys. The energy of a system as a function of time is given as E is a raised to exponential minus alpha t, where alpha is something. Measurement of A has some error, whereas the error in the measurement of time is this much. The percentage error in this much is how much. Now I'll tell you what. Whenever you have a physical quantity, one, which has some error in it, let's say delta P1, and some physical quantity 2, which has an error delta P2. Now, there are two things which you can do with it. Either you can add or you can subtract it. So let's say, for example, you are adding it in the first case. In the second case, you are subtracting it. And let's see what is the final answer that you get. In this case, your actual values P1 plus P2 will add. Here also these two things plus minus delta P1 and delta P2 absolute errors will add. Here obviously subtract P1 minus P2. But what is the funny part is this delta P and delta P that should still add even though it is subtracted. So this is what happens when you add or subtract physical quantities with certain errors in it. Okay, whenever you add the actual quantities. Whenever you subtract the actual physical quantities, but their absolute errors are always added. Now what happens when you have multiplication, division and powers? Well, let's say for example your physical quantity is some dimensionless constant p1 raised to alpha, p2 raised to beta, P3 raised to gamma, etc. Always bring everything on the top. Always bring everything on the top. Maybe this is minus gamma. I don't know. Something like that. Doesn't matter. The relative error in P, the relative error in the final physical quantity, K will not even come. Always take the modulus of every power and multiply it with the relative errors of each physical quantity. Always take the modulus of every single power. Yep. So P2 by delta P2 by P2. Again, take modulus of this delta P3 by P3. That's what you will do to find the relative error in the final physical quantity, provided everything is multiplied, divided, etc. Now, the problem in this is there is an exponent. There is an exponent in it. So you cannot use any of these formulas which I have just told you, which is there in the textbook. So you should understand what exactly has to be done when it is a non-standard format, which is neither addition, nor subtraction, nor multiplication, nor division. So then when you have the power itself containing that physical quantity, observe it, the power itself containing the physical quantity, then you have to think a little bit differently. So just like you do it for the mirror or the lens formulas in ray optics, basically you have to, for all the non-standard forms, use derivatives. Use derivatives and find the maximum possible uncertainty. Uncertainty. Find the maximum possible uncertainty. Yes, that d becomes converted into delta, which is that error. Take the derivatives and then find the answer. So you might ask, sir, then how do we do it in this particular case? Okay, so what is the equation? Energy is a square. Energy, let me write it on the next slide. Energy is nothing but a square into e is that exponent, minus alpha t, Okay, so this is minus alpha t. Okay, everybody fine till this point? Everybody fine till this point? First, I have written down that equation. Now I have to think about some derivatives, but before taking derivatives, let me write it in the logarithmic form. So that will be better. So log of e will be log of a square into e raised to minus alpha t. Okay. But log a into log b, sorry, log a into b is log a plus b. So it will be ln a plus ln e raised to minus alpha t. Oh, but wait a minute. I know this. Anything raised to something that inside the log, that power will come outside. So it will become minus into alpha t and we will have log of e. Now we all know log of e to the base e is 1. So this will be ln a minus alpha t and this will be nothing but ln e. Now, once I have got it in this form, after taking logarithms on both sides, we have taken log on both sides and then we got it in a much simpler form. Now I think it is better to take the derivatives. Now I think it is better to take our derivatives. Here if I had taken derivatives, it might look little more complex. So whenever exponents are there, the hint or the trick is try to convert into logs and then take the derivatives. So you will only see the magic which happens. Now differentiating. Now differentiating on both sides. So what we'll have? So let's say for example, d by, let's say we differentiate it with respect to I don't know, let's say x, okay, some random variable of ln e is equal to d, oh sorry, there was a square, so sorry guys, there was a square, I had to put a square here, so this 2 will come over here, 2 log a. Yep, so this will be nothing but 2 times of d by dx of ln a minus alpha is there, dt by dx. Now please remember e and a are not constants or else you will say they are 0. No, you use your chain rule guys, you will get the answer. Derivative of log of e with respect to e would have been 1 by e, but by the usage of chain rule you will put d by dx over here. Same thing 2 times derivative of log of a with respect to a would have been 1 by a, but because of the usage of chain rule you will put dA and by dx, and this will be minus alpha obviously dt by dx. Needless to say, you have to get rid of this dx and convert this d into delta, so therefore you will get delta e by e, I hope you can see it, delta e by e is equal to 2 times delta a by a minus alpha into delta t. Alpha into delta t. Everybody with me? Everybody with me? Perfecto? Yeah. Shouldn't we do it with respect to time? You can do it with respect to time. It doesn't matter. Anyways, if you do it with respect to time, that dt you can take it over here again in the end step. It really doesn't matter with what you take the derivative. Okay, with respect to. That's what I wanted to show you. So a lot of people think or get confused, sir, should I take it with respect to e or a or something? No, it doesn't really matter. Now you have all the values, guys. See this. I think measurement in a has an error of 1.25%. Error in measurement of time is 1.5%. So that is given to us. So I have an idea over here. I will write it as delta a by a minus alpha into delta t by t, and I will multiply it by t. This will be delta e by e. Let me convert everything into percentage. This delta a by a as given over here, how much is it? Has an error of 1.25%. So this is nothing but 1.25%. Then the error in the time is 1.5%. This is nothing but 1.5%. The value of alpha is given to be 0.2. The value of alpha is given to be basically 0.2. I think that value of time is also given. Yes, the time is 5 seconds. So the value of time is given to be 5 seconds, guys. Solve this and tell me how much answer you get. What is the answer that you get, guys? Come on, substitute everyone. Everybody substitute and tell me quickly. 2 into 1.25, that's 2.5. Yep, this is zero point 0.2 into 5, guys, that's 1. So 1.5, 2.5. Yes, I think you should get the answer as 4% if I'm not wrong. Just check this out. 4%. Very good, physics world. Amazing. Very good. Great. Awesome. Awesome. Yep. Yes, Harshini, I made it as 2 log A. I had changed it back then. Yep. So the answer will be how much? Very nice. 4%. Very good. Excellent. So beautiful question on the non-standard forms where you use derivatives and try to find the maximum possible uncertainty. But I know many of you would be worried about, sir, this minus was there. And then you would have got a wrong answer. I'll tell you what I did over here. I indirectly added. This is one of the most common mistakes. When you convert from D to delta, don't carry forward this sign. In fact, this will become now plus. Lot of you might have subtracted it. No, you have to add it, guys. Now you'll be wondering, sir, why did this minus become plus? See, there is a logic behind it. There is a logic behind it. Say, for example, there is plus minus 2% error in one quantity. Let's say there is plus minus 3% error in one quantity, and you are subtracting these two errors. Subtracting these two errors. I just told you, whenever you subtract errors, what happens there? Errors will always get added. You have to think of the maximum possible error in these things. So maybe when this first quantity had 2% error, then maybe the other quantity had negative 3% error. And when this quantity had minus 2% error, then maybe this quantity had positive 3% error. So in the first case, what will happen? 2 minus minus 3. 2 minus minus 3 will become plus 3. So it will become basically plus 5% error came. And in the next time, when the first had negative error, the second quantity had positive error. So minus 2 minus 3 will become minus 5%. So that is the reason why you will always convert that minus sign between two things for errors into a positive thing. Always add them. So how has this 5 come? It has come because of 2% plus your 3%. So same way over here, this minus sign, focus your attention over here. This minus sign has been converted into positive sign for the maximum possible value of uncertainty, because we are not sure. All of them might be positive error at the same time. Maybe one is positive, other is negative. So in that case, you have to take all the worst case scenarios. That is the reason why they get added. Okay, everyone clear? Isn't this the most amazing question, guys? I hope this is understood. Let's move on to the next question on your screen. If A and B are two vectors satisfying certain equations, what is the value of A bar minus B bar? So whatever is the theory, let's quickly go through it. So whenever you have the dot product of two vectors, remember it is nothing but magnitude of the first vector, magnitude of the second vector into cosine of the angle between them. This particular dot product can be used to check perpendicularity, and also to find the angles between two vectors. That is what you usually use this dot product for. And we also know that our I dot I, which is J dot J, which is K dot K, is equal to 1, whereas I dot J or J dot K or K dot I is equal to 0. Similarly, when you have A cross product with B, their magnitude is given by A, B into sine of the angle between them. Yep. And remember, their cross product is always 0 if they are parallel or anti-parallel And we know again over here also, if I have I cross I, which is the same as J cross J, because all of them are parallel to each other, they will be always 0. But if you do I cross J, I will get K. If you do J cross K, you will get I. And if you do K cross I, you will get J over here. So this goes in cyclic order, IJK, JKI or KIJ. They will always give you this. If you do anything reverse, you will get the negative of those vectors. Similarly, for vector addition and subtraction, if you have to find A bar plus B bar's magnitude, then the resultant has a magnitude of first vector square, second vector square plus 2 times AB into cos of the angle between them. But if you have to find the vector subtraction of the two, then the formula goes very similar, just that you have a square plus b square. Here you have minus 2ab cos of theta. This is the formula that you use for a bar minus b bar versus a bar plus b bar. Okay, vector addition versus vector subtraction. So let's move now to this particular question and see what is asked. A dot B is A cross B's magnitude. So A dot B, the dot product. So whenever you have the dot product, it will be AB into cos theta. A cross B, it is the cross product. So therefore it will be AB into sine theta. AB will cancel. So cos theta will be equal to sine theta. This can only happen when theta is 45 degrees. So what is the value of A minus B is the question. A minus B's magnitude. So A bar minus B bar will be root of A square plus B square minus 2AB cos 45. What is cos 45, my dear students? Yes, it is 1 by root 2. So it will be minus 2AB by root 2. So root 2 cancels and you will be left with A square plus B square minus root 2 times of AB. So where is that option? Obviously, it is there over here in option C. A square plus B square minus root 2 times of AB. Is it okay, my dear students? Clear? Very good. Option number C. So we are doing all the concepts related to the question with the question so that you know when to use what. And you are seeing the direct application of those concepts as it is. Very cool. Let's move. Let's move. Going to kinematics now. There were some 3 questions on motion in 1D and there were some, around 5 questions for motion in 2D in the January attempt. So let's see how it works out. Again, obviously, it's almost like 5 questions here and 3 questions here, around 8 questions bare minimum, which can be asked. So let's see some of the questions. Okay. Now there is a stone which is thrown. Okay, down with a speed, not speed of u takes time t1 to reach the ground. Another stone thrown upwards from the same point, same speed, takes time t2. The maximum height the second stone reaches from the ground is how much? Okay. So what are the concepts which will be used over here? Let's find out. First of all, whenever you are on the top of a tower like this, let's say the height is h. Now, if you drop something, this is very important. If you drop something, by the time it hits the ground, it will have a speed of root of 2gh. The time that it will take is root of 2h by g. This is dropping, that means initial speed is 0. But anything else you do from this particular height, anything else you do, let's say you have thrown this particular thing with certain speed u, then obviously the time will not be t as before. Then you have to use s is equal to ut plus half at square, v is u plus at, and your v square is u square plus 2as equations. You can use any direction as positive or negative. Let's say upward is positive, downward is negative. So the downward will be the acceleration due to gravity. Therefore, acceleration will be minus g. Acceleration will be minus g, and the rest of the things you have to use sign convention and follow the proper equations. You will get the answer. Okay. Now, also certain formulas for motion in 1D when you throw the object from the ground. If you are throwing the object from the ground, or forget the ground, just consider some random level. Just consider some random level, and from that particular level, you are throwing it up with some speed u. If it has to come back to the same level, then the time that it takes is 2u by g, and the maximum height that it reaches is u square divided by 2g. So these are the two concepts that we will be needing. Okay, all these concepts we might be needing for now solving this question. This is all motion in one dimension. Okay, let's go back now to our question and see what is exactly given. First time you are throwing the stone, how are you throwing it? Down. Next time you are throwing it up and the time taken is t2. So let me draw those two diagrams for all of you and see how it works out to be. Say this is that particular height. Okay, first time you're throwing it down like this with that speed u. It is taking some time t1, and next time you are throwing it up like this. It goes up, comes down like this, and then it hits over here. So it takes a total time of t2. In both the scenarios, if I assume the upward direction to be positive and the downward direction to be negative, and acceleration due to gravity will be obviously negative g, then see the displacement is always downwards. I was on the top, I came down, finally I am here. So displacement is in the downward direction, so it should be negative as per the signs that I have chosen. So using my equation, which equation? S is equal to ut plus half at square. Observe this now carefully. First time my displacement will be minus h. S is minus h. U is negative, so minus u into time is t1 plus half into g is negative because it is downwards into t1 square. So if I multiply with negative sign, I will get h is equal to ut1 plus half g t1 square. Similarly, if I apply the same equation for the second time, my displacement again is negative, so minus h is equal to initial speed is positive, time is t2 plus half into g is still negative minus g into t2 square. Okay, so I'll get minus h is equal to ut2 minus gt2 square by 2. Now look at this equation and look at this equation. I feel that I should add both of them. Maybe I will get something. So let's see what do I get by adding both of them. So let's add both of these equations and see exactly what do we get. So h and minus h will obviously be 0 on the left hand side. I will have u t1 plus u t2 plus half g t1 square minus half g t2 square. Okay, let's see what can we do next. Maybe I'll take these people on the other side. Maybe I'll take these people on the other side. So it will become half g t2 square minus t1 square, half g is common, is equal to u is common, t1 plus t2. Oh, this is a square minus b square, guys. So it is a minus b and a plus b. So t2 minus t1 and t2 plus t1 is u times t1 plus t2. t1 plus t2 will cancel. Oh, sorry, g was there. Yeah, so it will become g by 2 into t2 minus t1 is nothing but u. Oh, so I got the initial speed in terms of the times. It is g times t2 minus t1 by 2. I got that. Okay, but what is the question now? The question is something else. Maximum height for the second stone, it reaches from the ground. For the second stone, they are asking for the second stone. Keep that in mind. For the second stone, what is that height that it reaches? What is that height that it reaches? Let me keep it over here. So for that second stone, the height that it reaches will be this much height, plus obviously this much height, both of them added together. So we have two heights over here, guys. One is from here to here, and the second one is obviously from here to here. Out of that, this much part I know is already h. This much part will be u square divided by 2g. So this total will be, the total height will be h plus u square divided by 2g. This h plus u square by 2g. Correct, everyone? this h plus u square by 2g. Now what do we do next? Yeah. Anti-revenge, we have done most of the chapters, guys. Yeah. What do we do next? Come on, think about it. What do we do next? Is some formula there for h? I think so. We can use any of these formulas. Yes, we can use any of these formulas. Correct? Very good. So maybe let's say we use this ut1 plus half gt1 square. ut1, we can use, let's say, u times t1. That's it. U times t1 plus g t1 square by 2 from the previous slide, plus u square divided by 2g. Now this u here and here, I will substitute from here. That same u, I will substitute it from here. So observe carefully what will happen. So that u will be nothing but g into t2 minus t1, the whole thing divided by 2, of course. And that t1 will be there, plus g t1 square by 2 is also there, plus this 1 by 2g is there, and you need u square. U square means it will become g square into t2 minus t1 the square, the whole thing divided by 2 square, which is nothing but 4. So that is what I will essentially get. So this, carry forward it further. Okay. So how much will this be? Just have to see. G by 2 is common, I think, everywhere. So let's take G by 2 common, and you will be left with T2 into T1 into T1 minus T1 square. Here you have T1 square as it is, plus T1 square. And here, I think GG got cancelled. That's why G is out. 2 is also out. By 4 is there. And this positive sign is there. And this T2 minus T1 whole square, which is T2 square plus T1 square minus 2T1 T2. That is what I am going to get. Now this T1 square will get cancelled. This will become nothing but G by 2, and that will become 4 times T2 into T1. These two have got cancelled, plus T2 square plus T1 square minus 2T1 T2. The whole thing divided by 4. Minus 2 plus 4 is plus 2. So it will become G by 2. This will become T2 square plus T1 square plus 2T1 T2. The whole thing is divided by 4. 4 2s are 8. So it will become G by 8. This is A plus B whole square. So this will become T1 plus T2 the whole square. So G by 8 should be there, and T1 plus T2 whole square should be there. So we have solved it. Quite a lot of mathematical manipulation, but that is again something which you can expect in the April attempt, because you saw many questions which were quite lengthy out there. Yep. Okay. Yeah, there will be a course for JEE Advanced. It will be called Ekalavya, the entry point for which will be disclosed later on. Cool, guys. Amazing question. Shall we go ahead to the next one? Okay. Let's go, guys. Let's go. Let's see if you can answer this. This is very straightforward. There is a narrow but tall cabin, and it is falling freely near the Earth's surface. Inside the cabin, there are two stones, A and B, from rest. A is at a point higher than the center of mass, and B is below the center of mass. Is a close observation of the motion will reveal what? Come on, I want everybody to spam the answer. It's very direct question. You can easily get it. Yes, you can easily get it. Come on, think about it. Imagine a long, tall cabin. There are two stones. A is on the top, B is below. As the cabin falls, what will happen to those stones if you are seeing it from the inside of the cabin? One thing is very obvious, that it's clearly mentioned it's a tall cabin. So things have to be adjusted accordingly. This is the Earth's surface. This is that lift. This is where, let's say, the center of mass is of that thing. Ball A is over here, and ball B is somewhere over here. Think logically, guys. Where will the acceleration due to gravity be more? It will be obviously more here. So GB, whereas acceleration due to gravity over here will be less. This will be obviously more. And because it is tall, you have to consider that. It is clearly mentioned. It's a tall cabin. So you have to consider the height difference producing acceleration due to gravity difference. So obviously this ball will be moving faster and as compared to this ball which will be moving slower as compared to the center of mass. But yeah, I mean the center of mass will also be coming down, but it will be coming at a medium speed. You can think of it as a medium speed because the gravity here will be somewhere in between both of them. So if you sit on that center of mass frame, if you sit on that center of mass frame, center of mass is moving slightly faster than A, so A obviously will appear to go away from it. A will appear to go away from it. B is in front, it's below, and it's moving more fast. So point B will obviously appear to move slightly faster from it, away from it. A will go away, B will also go away, and they are both moving in the opposite direction. So I think A moves slowly upwards, B moves slowly downwards relative to the cabin. So I think it should be B option. Everybody got it? Everybody got it? Yes, everyone. Amazing, right? Amazing, right? What a question it was. What a brilliant question. And it was dealing with the difference in the gravity because of the heights. See, if the heights were small and close enough, then both of them will have same acceleration. Both of them will have same speeds. So there will be no relative motion. There will be no relative motion. So all of them will appear to be at rest. But when the heights are large, g is different, speeds are different, so there is relative motion. The one which is slower will appear to move slowly, drift apart from you. The one which is below will appear to move faster away from you. So it's faster, so it will go slowly away from you. Got it? Amazing. Moving on to the next question, guys, on your screen, and here it is. Now, there is a particle which is projected with certain speed at some angle, and it touches the inclined plane at some inclination. The height of the point from the ground where the particle touches the incline. Now, this looks like some crazy question. Read the question again. Be careful over here. This is the inclination. The particle is projected from here. This is not the projection. Okay. So, there is a roof over your head. Think of a roof, and that roof is sloping, and you are throwing a ball from below that roof, and it goes and it touches that. So this is that building or something like that. You're throwing it, it touches tangentially that particular inclination. And the question is, what height will it touch? That is the question. Okay. Maithili, no, there is no other batch for JEE Advance. It is the JEE Ekalavya batch only. So even our crash students will go into the Ekalavya batch. Every student will go into the Ekalavya batch for JEE Advance. All right. So all the students who clear JEE mains eventually go up to the JEE Ekalavya batch. Correct. Okay. These are not necessarily PYQs. Okay. Now there is a concept in our projectile motion, if you remember. One is basically, if this is theta, okay, this is u, no matter where you go, there is this horizontal speed which is u cos theta. That speed remains constant throughout that particular motion. So it is always going to be u cos theta, which is constant. And the reason for that is because there is no acceleration in the x direction. But this y velocity is not constant. It is not constant because there is acceleration in the y direction, which changes the y velocity. So I think we have to use that concept somehow over here. So I'll tell you what. First of all, see, when this ball is at the bottom, then it has some horizontal speed. This was the actual speed. This would be the horizontal speed, which will be u, which is 50, and cos 37. When it goes and touches the inclination over here, yes, the actual velocity will be tangential. Actual velocity will be tangential, and it will be along that incline because it is just touching, grazing through that surface. But at the same time, it will have some horizontal velocity. If this velocity is v, this angle being whatever that 30 degrees, this will be v cos 30, v cos 30. And these both must be equal to each other. They both must be equal to each other because horizontal speeds are always going to be a constant. Horizontal speeds are always going to be a constant. So let's make use of that. 50 into cos 37. Cos 37 is 4 divided by 5. Sine 37 is 3 by 5. 3, 4, 5 magic triangle. And velocity into cos 30. Cos 30 value is root 3 by 2. 5 and 50 cancels, becomes 10 multiplied by 4. This 2 also goes on the top, will become v multiplied by root 3. So therefore, our velocity will become 4 2s are 8, 8 10s are 80, and this root 3 comes below, so it will become 80 by root 3 meters per second. 80 by root 3 meters per second. Everybody with me? So I found that velocity. Now you will be like, sir, why the hell did you find that velocity? Because I wanted to find that height. Yes, I wanted to find that height. That is the reason why I did it. How will it help me find the height? Simple logic, guys. Use kinematic equations in the vertical direction. It will give you everything. Displacement in the y direction can be found out. I don't know the time. So use Vy square is nothing but initial velocity in the y direction square plus 2 times acceleration times displacement in the y direction. Everything you know in the y direction, you can get every single thing, guys. Y velocity over here, can you think it will be v sine 30? Yes, this will be nothing but Vy, which will be v sine 30, which is nothing but 80 by root 3 multiplied by half, which is 40 by root 3, which is 40 by root 3. So Vy square will be 40 by root 3 the square. What is initial velocity in the y direction? Well, that will be only this much velocity. So that will be uy, which is 50 sine 37. Sine 37 is nothing but 3 by 5. So 5 cancels. So it will be 30 meters per second. So this will be 30 square plus 2 times acceleration is negative 10 and displacement in the y direction. This is the displacement in the y direction, which is h. That's it. Solve this and you will get the value of h, which comes out as 55 by 3 meters, which comes out as 55 by 3 meters. Is that okay? You just have to solve this. You will get it. Everyone understood? Beautiful question on kinematics and also the concept that horizontal velocity remains constant. Horizontal velocity remains constant. How many of you loved this question? Quickly smash that like button down there and show some show some symbol or emoji, maybe a heart or a fire in the chat box, because I love this question. Because usually you throw it from above the inclined plane. First time you are throwing it below the inclined plane and it just grazes through it tangentially. So the velocity was tangent over there and the horizontal component will be same as before because there was no acceleration in the x. Bala, how to remember sine cos 37 of all these things? So remember the magic triangle. Remember the magic triangle. What is that magic triangle? I'll just give it to you over here. What is a magic triangle? 5, 3, and 4. Because we all know this is a Pythagorean triplet. 5 square is 3 square plus 4 square. Right? Now, do you see the numbers 5, 3? 5, 3, 53. 5, 3, 53. So this is basically 53 degrees. Obviously, this angle will be 37 degrees because this is going to be 90 degrees. Now you can find anything. Sine 37, 3 by 5, opposite by hypotenuse. Cos 37, 4 by 5. Tan 37, opposite by adjacent. Cos 53, 3 by 5. Sine 53, 4 by 5. Cot 53, 3 by 4. So anything you want, you can find it. Got it? Easy peasy. 5, 3, 53. Whichever has the sides 5, 3, that included angle becomes 53. Opposite other angle will become 37, the complementary angle. Okay. Sanket, I hope this magic triangle is absolutely clear. Entire event series, Bablu, is over. This is a new series. Come on. We completed all the high weightage topics in anterior bench. Yep. Moving on to the next question on your screen. Wow, a disk is given. Crazy. And it is projectile motion problem because I can see the range of the disk is asked. And there are 2 points, the topmost and the lowermost point. Their velocities are given. Then, if it goes in a vertical plane, the question is, what is the range of the disk? At the start, this question seems to be very strange. As in, like, you might be wondering what the hell is happening over here. Why are these top and bottommost point of the velocity of the disks are given? How will it help me find the range? Because usually we take particles and we throw it and we find the range easily. But here is the logic. Observe carefully. Imagine this is our disk. This is our disk. Okay. The topmost point over here, which is, let's say, A, has a velocity of 20 I cap and how much? 10 j cap. This particular point B has a velocity of 10 I cap and basically 10 j cap. This is 10 j cap. I feel the only thing I need is what is the velocity of the center of mass. We just need what is the velocity of the center of mass. That will be enough for me to consider the disk as a point object. Think like this. This is our ground surface and maybe this is our disk. If I just know what is that velocity of the center, what is that velocity of the center, that is enough for me to find where exactly will it land. I just need the velocity of the center of the disk. So how do you find the center of the disk's velocity? Just take the average of the two. Just take the average of the two velocities, you will get it, guys. So essentially, your velocity of the center will be nothing but velocity at the topmost point plus velocity at the bottommost point upon 2. So which will be nothing but 10, sorry, velocity of A is how much? 20 I cap. So it is 20 I plus 10 J plus 10I plus 10J, the whole thing divided by 2, which will give me 20 plus 10, 30, 30 by 2 is 15. So 15 I cap, 10 plus 10, 20, 20 by 2 is 10. So 10 J cap. So this is velocity of point C. Yes, this is the velocity of point C. Now this is basically the horizontal velocity. This is basically the vertical velocity. From the vertical velocity, we can easily find the time of flight. The time of flight is always nothing but 2 times the vertical velocity, 2 times the vertical velocity divided by g. 2u sine theta by g. U sine theta is the vertical component. So it will be 2 times 10 divided by g, which is also 10, which will give me 2 seconds. Now similarly, the range of that particular projectile, the range of the projectile is the horizontal velocity into the time of flight. Horizontal velocity is nothing but 15 and the time of flight, we just figured it out to be 2 seconds. So that will be nothing but 30 meters. So 30 meters is option A, guys. Yeah, it is nothing but option A. Isn't it amazing? Loved the question. The disk was having some dimensions and 2 velocities were given. So you found the velocity of the center of mass and then you proceeded with the question. What an amazing. No, there was no need to skip this question on disk. Yep. Yep. There was no need to skip this question on the disk because it looks initially difficult, but it is not. All right. So let's go to some questions on laws of motion, spring forces, banked roads, all these things. So there were around 4 questions to 5 questions, at least in your January attempt. So let's start with a question where a block on block is given and this block is given some speed. This block, I think, of the same mass is shown and initially only A is given some speed. The bottom guy is not given any speed. If V1 and V2 are the speeds of A and B, with the time they will change. What is the correct graph of variation of both these speeds? Will speed 1 reduce, speed 2 increase and achieve common speed? Speed 1 reduce, speed 2 increase linearly and achieve a common speed? Speed 1 and speed 2 decrease, increase, and then their speed combines and becomes slower. Speed 1 keeps on reducing, speed 2 increases and then decreases. So you have to think logically, guys, what exactly might happen in this particular question. Yeah. What exactly might happen in this particular question? Think logically, guys. Well, initially, please remember, the plank is placed over a smooth. Yeah, the bottom surface is smooth. This guy has some speed. This guy does not have speed. So let's take some cases. Let's take some cases. Only the top one has some speed. The bottom one does not have any speed. Hmm. Observe now. So this guy has V1 is equal to V naught is equal to V naught. This guy's velocity is 0. It is at rest right now. So if it is at rest, the top one is moving. There will be friction on the top one like this, and it will be this way. The reaction on the bigger block will be like this. So the bottom one will accelerate and the top one will decelerate. The top one will decelerate, this one will accelerate. So if they will accelerate and decelerate, their acceleration will have some value because the frictional force is a constant. Their deceleration or acceleration, which is that frictional force divided by that mass. Frictional force is obviously a constant, mass is a constant, obviously. So therefore, the deceleration or the acceleration will be constant in magnitude, will be constant in magnitude. If the deceleration or the acceleration is constant in magnitude, what does it tell you about the velocities? What does it tell you about the velocities? Therefore, the velocities will increase or decrease uniformly. This is very, very important. They will increase or reduce uniformly. Therefore, the velocity versus the time graph should be 100% a straight line. Should 100% be a straight line. So if you go back into the options, can you see this is not a straight line? This is not a straight line. This is also the curved graph. This is also curved graph. This is not a straight line. So the only possible options are B and D. Only possible options are B and D because curvature cannot be existent. Is that okay? Fair enough. Next, after this, what will happen? This guy will get some speed reduced. Yep. This V1 will be slightly less. This V2 will be slightly more. Still, there will be friction on both of them. This guy will experience some friction. This guy will experience some friction. They will still continue to increase and decrease their speeds. Again, this guy will again decrease its speed. This guy will increase its speed more. And this will continue till both of them have a common speed. Let's say Vc. So this V1 is equal to some common speed, V2 is equal to some common speed, because this is reducing, and this one was increasing till both of them basically became the same and they had a common velocity. Then what will happen? The friction in between them will be zero. The friction in between them will become zero. So now below surface is absolutely smooth. Below surface is absolutely smooth. So there is no reason for them to accelerate or decelerate further. So whatever is this common velocity, this common velocity, this common velocity will remain constant because there is no retardation further. There is no retardation any further. Is that clear? There is no retardation or acceleration any further. So it will maintain its velocity. So that means it should remain like this. It cannot go down any further. Yes, this was your common velocity. Hence, the correct answer, I think, should be option B. Yep. Check this out. Option B. How many of you got it? Very good, Jarvis. I think you said option B. Perfecto. Perfecto. Amazing. Amazing. Amazing, guys. Kudos. Those of you gave the answer as option B. Let's go to the next question. It's a beautiful question. Wow. Look at an inclined wedge on which there is a groove itself which is inclined. It's crazy to think about it. There is a wedge which is inclined, and on that, the groove itself is at an angle. So the question is, the time taken by that object to go from point A to point O is how much, given that the groove OA's length is given. So I just need to use kinematic equations. Think about it. If I use S is equal to UT plus half AT square, the displacement is already known to me, which is 5 meters. Initially, it was at rest, is free to slide. The time taken by it to reach from A to O, so it will be 0 plus half into acceleration, I do not know, into time square. Solving this, obviously, I shall get the value of time square, but the problem is, what the hell is this acceleration? What the hell is this acceleration going to be? See, this is the acceleration that I want. This is that acceleration which I want along that line. So let's think carefully now. Let's think carefully. Let me create a duplicate. Okay. Now, look at it from sideways. Look at it from sideways for a second and see how does it look like. It looks probably like this with this particular angle 30 degrees, and this plane will be like this. This plane will be like this. This plane in which this entire groove has been made. Now we all know that acceleration due to gravity is downwards, but we end up splitting that particular acceleration into two components. So if this is G, there will be one component like that, and the other component will be along that plane. So this would be G cos 30 degrees because this angle will be 30 degrees, and this will be basically G sine of 30, which is G multiplied by half, which is nothing but I would say 5 meters per second square, because G is 10 by 2 will make it 5 meters per second square. So this 5 meters per second square acceleration which is there, that is the acceleration down the incline, acceleration down the inclined plane, acceleration down this particular inclined plane. Down the inclined plane means like this. So if somebody decided to fall off the inclined plane like this, that guy's acceleration would be 5 meters per second square. But I'm not going down the inclined plane. I'm going at an angle with the inclined plane. So you need to be really careful over here. Observe now, if this is 30 degrees, obviously this is going to be 60 degrees because this is going to be 90 degrees, guys. Yep. Is that clear? So down the inclined plane, the acceleration is 5. If this groove is making 30 degrees with the bottom, that groove will make 60 degrees with the down of the inclined plane. This 5 will have two components. This 5 will have two components. Obviously, one component will be here like this, and the other component will be perpendicular to that. Other component will be perpendicular to that, maybe something like that. I'm not interested in that. Just check how much acceleration is there down that groove. So acceleration, so the acceleration, that particular acceleration along the groove, acceleration along the groove, if it is A, how much will that A be? It will be this guy's cos 60 component. Cos is closer, sine is the far away component. So it will be the cos component of 60 degree, which is 5 into half, which is just 5 by 2 meters per second square. How many of you got it? The acceleration along that groove? How we found it? By taking the component of the component. Yep. So coming back to the original question, this questionable value is nothing but 5 by 2. This is nothing but 5 by 2, which we just figured it out over here. So substitute it. So this will therefore become nothing but 5 by 4 into t square. 5 cancel. So 4 will be t square. Therefore, time will be 2 seconds. So time will be basically 2 seconds. Yes, it is 2 seconds. It is definitely 2 seconds. Did you love the question, guys? Because this involved components, and expect these kind of difficult questions in your April attempt. This is not even difficult, I would say. This is just taking a component of a component at the end of the day. Yep. Before Bombay, awesome, bidding talent. Akshit, sir deserves a raise. Ooh, thank you. Thank you for giving me that promotion and extra money and extra salary, guys. At least on paper. I am very happy. My salary has been increased on paper. Okay, cool. Moving on to the next question, guys. This is also a beautiful question. M1 and M2 are connected by a spring. There is a platform below. And now what is happening is the spring is massless and the coefficient of friction is mu. What do you think will happen if you pull the plank with some acceleration? And let's say you are changing the value of acceleration. Maybe first time it is less, then you make it more. So maybe there might be some conditions, maybe nothing will happen no matter what it is. So you need to figure out what will happen. Will the spring elongate? Will it be compressed? Masses are different, please note it. And nobody is telling you M1 is more or M2 is more. So we need to figure that out. Okay, come on, my dear students. What do you think would be the answer for this particular question? Okay. Now, in these kind of questions, when there is a block kept on a particular plank, okay, so let's go to the concept over here. Let's say this is our plank, and let's say this is our block, and our plank is pulled with some acceleration A, and this particular mass is, let's say, m1. It will experience many forces. Obviously its own weight will be there, m1g will be there. There will be a normal force, pseudo force will be there, which will be m into a. This is your pseudo force, exactly backwards in that non-inertial frame. Friction will prevent you from slipping. So if you shouldn't slip, if you shouldn't slip, okay, you shouldn't slip, then your pseudo force must be less than the maximum value of the friction, which is mu into mg, or mu into n, you can say. But we all know the normal force in this case will be mg. So ma should be less than mu mg. So therefore a should be less than mu g. Okay, so a should be less than mu g. When it is there, then it will not slip. Best part, it is independent of the mass. It is independent of the mass. Okay, so for it to not slip till the acceleration is less than mu g, the mass has no role to play. Mass has no role to play. But what happens when it begins to slip? So then there will be some relative acceleration. So there will be some relative acceleration. We can find that. Okay. So ma will be behind and friction will be opposing that acceleration. That will be equal to m into a. So therefore, our friction will be mu into n, which is itself mg, is equal to m into a. MMM cancels. This is, please remember, this is relative acceleration. So MMM cancels. So the relative acceleration is a minus mu g, which is still independent of that mass, which is still independent of that mass. Now, how does this apply over here? Just think logically now. If this is the plank, these are two masses, forget the spring between them. Forget the spring between them. This is M1, this is M2. Okay. And let's say in the first case, our acceleration is less than mu g. Then what will happen? Then both will not slip. Both of them will not slip. Is that correct, guys? Both of them? Definitely, they will not slip. This mass number one and mass number 2, they will not slip. So there will be some distance between them. So that distance between them, therefore the distance between them will be constant. Distance between them will be constant. So the spring, if for present, will neither compress nor elongate if A is less than mu g. If A is less than mu g. What will happen if A is now more than mu g? What happens in that particular condition? Then there will be some relative acceleration. Then both will have same relative acceleration and motion. If they have the same relative motion, what will happen to that relative distance? That relative distance will remain constant, guys. That relative distance between them will remain constant because it's independent of the mass. M got cancelled. So if there was a spring present, that will neither elongate nor compress. So in either case, it is not changing the distance. So the spring should neither extend nor compress. It will remain the same under all the conditions. So D for IIT Delhi. D for IIT Delhi. How many of you loved the concept and loved the explanation and how this works? Pure usage of Newton's laws and relative motion. Clear? Is this concept clear? Everyone, come on, show that Josh, guys. Gautam, ADS, Akshit, Vaishu, come on, everyone. Akshit, Gina, Budding Tamil, Gauri. Yes, clear? Very good. Very good. D option. Very good. Very good, Jarvis. Let's move to the next question. There is a particle which is moving in a circle of equation x square plus y square is equal to a square in the anti-clockwise direction in the xy plane, which is rough and stationary. So no question of pseudo force. There is some random point a cos theta, a sin theta, unit vector of the direction of the friction on the particle. Let's take a moment to understand what is happening. Covered, it's just that in the previous question, it so happened that first I thought of a singular mass and what is happening in two cases. When it is not slipping, then what's the condition? And when it slips, what's the acceleration? Both times I found it is not dependent on the mass. So mass has no role to play, M1, M2. Then I thought, forget the spring, just keep the two masses and let the plank move. What is happening? As long as the acceleration is less, the two masses are maintaining their distance. When you move it with faster acceleration, both of them start to move relatively, but their distance never changes. So if you connect a spring between them, what will happen? It's anyways massless. So the distance between the two ends of the spring will not change, which means the spring should neither elongate nor compress in any condition. So under all conditions, the spring will be at its natural length. Is that clear, everyone? Okay, covered. Perfect. Now, how to solve this particular question? See, guys, by mistake, I think I showed the answer also. Anyways, concentrate now. So let's say this is our x-axis. Let's say this is our y-axis. You consider a random point over here, and this is nothing but a. This is nothing but theta. That is a cos theta. That is a sin theta. If it is going in the anti-clockwise direction like this, therefore friction should always oppose that motion, and friction will be like this. So this is how the direction of friction will be. Friction always opposes relative motion. That is what we have seen every single time. Always opposes relative motion. So we'll do one thing. Let's drop a perpendicular over here. Let's drop a perpendicular over here. Things will be even more clear. See, this is nothing but 90 degree. This is nothing but 90 degree. So if this is 90 degree, this will be 90 minus theta. This will be 90 minus theta because this is theta, that is 90. So this will be nothing but 90 minus theta. And we know that this whole angle is 90 degree. This complete angle is 90 degree. So therefore, this particular angle will be theta. This particular angle will be theta. Everyone? So This friction will have two components now, one like this and the other one like this. One will be obviously F sine theta. This is nothing but your F sine theta. The downwards will be F cos theta. So F sine theta I cap, because it is in the x direction, F cos theta will be in the j cap direction. So negative j cap, because it minus j cap direction. So this is your friction, but we want F hat. F hat will be F sine theta I cap minus F cos theta, sorry, minus F cos theta j cap. The whole thing divided by the magnitude of that vector. FF will cancel. So F hat will be sine theta I cap minus cos theta j cap. So sine theta I cap minus cos theta j cap is the answer C. Here, all that I have used is this concept of any unit vector will be that vector itself divided by the magnitude of that vector. The magnitude of the vector is F. The vector itself was this. Okay, is that clear, everyone? Option C. Loved it? Yes. Beautiful, beautiful, beautiful. Okay, very good. Let's move to the next concepts from work power energy, where around expected questions were around, some 7 questions and all, overall. So decent chunk of questions were asked. So let's see some questions based on that. So here we have two springs and a block in between. The two springs are now at natural length, and now you are moving that block by some amount x and releasing it. How much speed will it have when it is at a distance of x by 2? Now, always these kind of questions involve two kinds of concepts. First is the energy conservation concept, conservation of energy, conservation of mechanical energy, where kinetic energy plus potential energy will be final kinetic plus final potential. And also in that, you should know that the spring potential energy has a formula of half kx square. The gravitational potential energy for small heights is mgh. This is when h is much, much smaller than the radius, of course. And the second concept that you have to use is springs in series and parallel. So whenever you have these kind of combinations, or let's say a spring is here, block is here, and a spring is here, the equivalent spring constant, they are considered to be in parallel, guys, one beside the other, or one here, one there. This is also parallel only. Instead of placing the spring here, you are placing the spring there. So it's one and the same thing. Then the spring constant will be K1 plus K2. But if you have one spring like this attached to the other spring like this, and then there is a block, they are considered to be in series. And then 1 by the spring in series effectively is 1 by K1 plus 1 by K2. This is considered to be series combination which has parallel resistors formula. This is considered parallel formula, oh sorry, parallel combination, but the formula is of series resistance. So this is a parallel combination. Okay, so these are the concepts used in this particular question. Now let's see how do we exactly apply them. Look at this problem. You will immediately see the two springs are besides each other. The two springs are basically besides each other, so parallel. So effective spring constant, immediately I will get it. So instead of putting two springs on the sides, both sides, I will just get rid of one of them. And then I will write the effective spring constant because they're in parallel. So it will be just K1 plus K2. So this is just K1 plus K2. Is that okay? Right? Now, if the spring is compressed by some amount, let's say on one side, if it is compressed by some amount, okay, by let's say X amount, here it was at rest, and by the time it reaches a value of X by 2, by the time it reaches the value of X by 2, it has some velocity. It has some velocity. So obviously from this point to this point, energy is conserved, but the potential energy got converted into kinetic energy. So it was at rest, the spring was compressed. When it came back here at x by 2, that potential energy has got converted into kinetic energy. So let's use the energy conservation logic. So potential energy when it was compressed plus that initial kinetic energy will be potential energy when it was at x by 2 plus the final energy. Potential energy when it was compressed will be half k, but that k will be the total k, which is k1 plus k2 into x square. It was at rest, so put 0. It was at rest, so put 0. Potential energy when it was at x by 2 will be half total k, which is k1 plus k2 into x square by 4, because x by 2 whole square, plus final energy kinetic half m v square. That's the formula. Half, half cancels. So I am left with k1 plus k2 into x square. K1 plus k2 into x square is equal to k1 plus k2 into x square by 4 plus x square by 4 plus mv square. So therefore mv square will be this and this, take it together. So you will have k1 plus k2 into x square. 1 minus 1 by 4, you will have 1 minus 1 by 4. 1 is there, here 1 by 4 is there, which is 3 by 4. So therefore v square will be k1 plus k2 whole thing divided by m. Here you have x square. This will be nothing but 3 by 4. Therefore v will be root of all these things. You will have k1 plus k2. Here you will have m. Here you will have x square. Here you will have 3 and 4. So therefore, that's it. I think they have not taken anything outside the root. So just leave it like that. Yeah. So I think it should be option labeled B. 3 by 4 k1 plus k2 x square by m. Can you see that? Exactly this particular option. Cool, guys. Everyone, yeah, B option. Perfecto. Yeah. Very nice. Amazing. 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 Let's go to the next question on your screen. Look at this. Again, a very different model of question which involves multiple concepts. There is a mass. It is there in a hollow cylinder of radius r and height h. It's hollow, vertical. And a small mass is placed at the contact in the inner side of the upper rim. Sorry, this is the upper rim, this is the lower rim. Okay, and you are giving it some velocity horizontally. Okay, horizontal speed u, tangential to the rim. So it goes like this, but it won't keep going like that because of gravity. What will happen? That mass will slowly start going down and it will go like this, like this, like this, like this, like this, and it will slowly come down. Is that right? It will slowly come down. And it leaves the lower point exactly below A. And there is an integer which is related to these variables. How is that integer related to these variables? This integer is basically how many number of times does it go around in that inner part of the cylinder. This integer is how many times it goes in the inner part of the cylinder. Okay, let's see, guys. First of all, I don't need these options. Read the question again. See if you can make some equations. We know that this point and B, A and B are one below the other. The velocity initial velocity is in horizontal plane only. So if you ask me what is the initial velocity in the y direction, it will be 0. And eventually final displacement is in y direction, okay, is in y direction from A to B. This is from A to B, okay. And there is also acceleration in the y direction, which is there downwards. So that's why negative g, okay, fair enough. This reminds me of one-dimensional motion. This reminds me of one-dimensional motion of free fall. This is just like free fall. So you drop something, it accelerates down by some height. and it reaches over here in some time. So this is one dimension free fall motion. This is one dimension free fall motion. So that time should be root of 2h by g. That is the formula. One dimension free fall, the time taken to fall is root 2h by g. So this entire event will take root 2h by g, because gravity is the only force acting downwards. Nothing else is there. It's a smooth cylindrical wall. Clearly mentioned. It's a smooth cylindrical wall. So only gravitational force is there. Okay. Next. Now let's figure out what will happen in the horizontal plane. See, in that horizontal plane, it will go in a helical path like this. So it will be like a helical path. It's like a helical path. Every time it completes a circle, it is completing a circumference. So n times if it moves, the circumference, n times if it moves the circumference, that will be the total distance traveled. The total distance traveled. That total distance is obviously the multiplication of the speed which it has multiplied by the time. Speed multiplied by the time. So n times the circumference, which is 2 pi r, is speed, which is u, and the time we just got it from here, which is nothing but root of 2h by g. So therefore, take this 2 pi r below. Therefore, n will be u divided by 2 pi r, and then you have root of 2h by g. So this is what that integer will be. N is the number of times it completed the revolutions. The number of revolutions, this is number of revolutions that it completes. So that is what the answer should be. U by 2 pi r, root of 2h by g is nothing but your n. Is that absolutely clear, everyone? How many of you loved this question, guys? Nice, right? It had two concepts: vertical 1D motion and speed into time was the distance, but the distance was completed many times in horizontal circles. It was going like a helical path. So 2 pi r, 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 n times it went before it came down. Yeah, correct. Beautiful. Amazing. Amazing. Moving now to the next question. Let's go. There is a bob which is suspended from the crane. Bob which is suspended from the crane. I can show you over here. Yeah, it is suspended. This is that crane, and this is that trolley or whatever. Length of the pendulum is 5 meters. The crane is loaded and moving at a speed. The crane is stopped. It is moving, it stops. So when you suddenly jerk and stop, whatever is there in the front will move because of the because of the inertia, and it will go like this. But since the bob was tied to the pendulum, it will swing and reach certain height, and it will come back. So it will go up till a certain point, and the angle by which it swings is 60 degree. So the question is, what is that initial speed? The logic for this is, see, initially when it was vertical, the entire thing was having the bob, the pendulum, the crane, the wheels, everything was moving at V0 speed. Then what happens is, because of the sudden stop, that velocity was there, it behaves like a pendulum with initial velocity at the bottom, reaches till this point, and it stops over here. This angle being 60 degree, I believe. That is what is given. Yeah, 60 degree. So potential and kinetic energy is converted into potential. So I just need how much height is this. This particular height will be the total length of the pendulum minus this particular part, which is the length of the pendulum's cos 60. So it will be L cos 60 over here, which is 5 minus 5 into half, which is just 5 by 2 meters. So the height by which it goes up is 5 by 2 meters before coming to a complete halt. That means a rest. So use energy conservation. So initial kinetic, initial potential is final kinetic, final potential. Initially, it had half m v naught square, zero potential energy. If we take this as the standard reference, finally, it was at rest. Final potential energy is mgh. Mm cancels. So v naught square will be 2gh. So this will be 2 into 10 into height. Height is nothing but 5 by 2. So 2 cancels. So this will be nothing but 50, but that is V naught square. So V naught will be root 50. Root 49 is 7, so approximately 7 point something. So B will be the answer. Yeah, B will be the answer. Perfect. So 7 meters per second. Correct. Very good. Awesome. Awesome. Guys, some people have come here to do some time pass. You guys will be getting blocked. I think already you guys are blocked now by the admin. So please concentrate on the class. This is not the time for flirting. I mean, if you want to flirt, there are many options. Okay. But YouTube chat, I know what you guys think. You guys are showing to your parents that you are studying by watching somebody's class, but I know there are secret codes, secret discussion groups, and God knows what and all other cryptic material you have. So you show to your parents that you are studying, but you are on YouTube sending secret chats to your so-called beloved lover, probably who have not seen or you have not met also, and you think that you are going to get a response and things are going to work out. Guys, you must be really, really the most optimistic person in the entire world if that is what is going to happen. All the best. If that optimism could be rather used to clear your entrance test, I believe you can do wonders. Correct. Yes. Okay. Thank you so much, Mini. Thank you so much. Yeah, modern physics also. Modern physics also. Let's move to the next one. Circular motion. There were many questions on circular motion which were asked this time, but there were also some special questions which were out of the way. And let's do some questions which are slightly off track. And you know the funny part is students think that teachers over here do not understand what they are doing, and we can just chat over here and do things. But guys, we knew this from day one. I mean, come on, what do you think? We also were kids like one day, and we have been through the entire process. And we used to have different methods during those times. And obviously, technology was not that advanced during my times, and we did not have YouTube. But the best way to approach someone is not through online. Just go and talk. Have the guts, because through online, through through a social media account, approaching anyone is nothing. I mean, it doesn't take guts. If you have the guts, go front, go in the front and strike a conversation. That is going to build that confidence and personality, not hiding behind some fake account and doing all this nonsense. Yeah. Hmm. A particle moves with a deceleration along a circle of radius r, so that at any random time the tangential and the normal, means tangential and normal means centripetal, accelerations are equal. Oh, there are two accelerations for circular motion, tangential and centripetal. Both of them are equal. They change accordingly. The initial moment speed is v naught, and the speed with distance is given by which particular function? Yep. Come on. What do you think is the correct answer for this particular question? Come on. Let's see. Let's see. First of all, let's understand what does it mean by this particular statement, equal in moduli. So a tangential modulus is a centripetal modulus. Tangential acceleration's value is dv by dt, just the rate of change of speed, and centripetal is v square by r. That's it. But nowhere in the entire question or the options I can see time involved. I mean, yeah, this is there, but most likely it is a question on speed versus distance. So time should be somehow eliminated. I want to get rid of time. Yeah, I want to get rid of time. How do I do that? Chain rule, guys. Yep. dv by ds into ds by dt is equal to v square by the radius. Now, what I can do, this ds by dt is velocity. So dv by into v, and this whole thing divided by ds is as it is there, is equal to V square divided by R. Perfecto. Okay. Next step, observe carefully. V cancels. This V comes below. So it will become dV divided by V is equal to, this ds goes on the top. So ds divided by R. Now I feel this is integrable. Yep. So I can integrate dV by V is equal to dV by V is equal to 1 by R. It's a constant integral ds. So initially the speed was V naught. So the distance will be 0. The speed will be V naught. When I have covered distance S, the speed will be V. The speed will be V. Okay. So what is 1 by V's integration? It's 1 by X's integration, which is log of X. So this will be ln V and then ln V naught also. Then subtract them. Will be, because upper limit and lower limit, 1 by R, and integration of ds is S. So first put S, then put 0 and then subtract them. Okay. So log A minus log B is log of A by B. So ln V by V naught is equal to, this will be just S by R. Perfecto. What next? Take it in exponent form. So it will become, therefore, V by V naught is equal to e raised to S by R. But in this whole process, there was one thing which we completely ignored, and I'll tell you what that is. Any guesses? Any guesses what we ignored? This part, it was deceleration. So technically, if it was deceleration, this should have been minus dV by dt the moment I removed the moduli. The moment I removed the moduli, this should have been minus dV by dt. So everywhere there should have been a minus sign, minus sign, minus sign, minus sign, and minus sign, of course, with a minus sign. And this will be then minus S by R. So the next step will be V is equal to V naught into e raised to minus distance divided by R. Minus S by R V naught is option A, I believe. Yes, it is option A. Yes, it is option A, not B. B will be true if you ignore the minus sign and see how tricky the options are. Both the things are there, minus S by R and plus S by R. If a student misses this word, he will miss the minus sign. Don't worry, even if you miss the minus sign, the computer scanning your sheet will give you that minus 1 mark. Okay, so the minus sign is still conserved. If you miss the minus sign here, you will get minus 1 the moment you mark B. Amazing question, guys. Yeah, that's why many of you said B, but I realized it the moment I reached this step. Yeah, missed something. I didn't feel it should be e raised to S by R, because then it will be increasing in value, but it was decelerating. So if it was decelerating, it has to be a negative exponent like a decay, Yeah, great, great. Let's go to another question, guys, coming up on your screen. Yep, ready for it? There is a particle which is thrown in a field whose coefficient of friction varies as A by R square, where R is the distance from the origin in meters and A is a positive constant. The initial distance of the particle is 1 meter and its speed is radially outwards. The minimum initial velocity at this point of time. It's crazy question, guys. Just look at that question. See, imagine concentric circles, and in each concentric circle the coefficient of friction is constant because mu is dependent on R. Observe it carefully. So if you go to any R distance anywhere over here, the mu value is a constant at that R, which is A by R square, constant on the circle, constant on that particular circle. But if you change the circle, mu will change, obviously. Now you are, say, 1 meter away. So let's say this is 1 meter, and you are throwing it with some radial velocity. Crazy. You are throwing it with some radial velocity, let's say V naught. You are at 1 meter distance and throwing it with some radial velocity. So what will happen? Mu will change As you go to the next and next and next circle, friction will change. But still, what should happen is that this should continue, this motion should continue, and you should reach almost the infiniteth circle. The infiniteth circle. This is the last circle, the ending circle. This is the infiniteth circle. And there also, you should have negligible velocity to just reach outside the universe. So almost 0 meters per second velocity. So that you are never stopping. Never stopping means you reach infinity with minimum velocity of approximately 0. Is this question now understood, my dear students? How many of you now understood that particular question? Oh, I look like Indian Elon Musk. Oh, thank you so much. I take it as a compliment only because yeah, some people love Elon Musk and some people hate Elon Musk for his radical ideas. So I know I don't really care about what the haters say. I only care about what is good for the students. I only care about what is good for the society. Yes, I believe in that particular ideology. So that way you can relate me to Elon Musk. Perfect. Because you have to think about the bigger picture. You have to think about certain aspects for the students. Even if students say, no, sir, we don't like it, but I know if it is good for you, I will do it. I know if it is going to benefit you, I will do it. Yeah, because I've seen through experience. So, my dear students, what do you think is the way to solve this? Obviously, integration is involved. You can see some functions and all of that. Huh. What will you use? What will you use? So, if the coefficient of friction is given, acceleration, velocity, distance, and it should never stop. Okay. So, how about using work power energy concept and the concept of work kinetic energy theorem? Work kinetic energy theorem, which says the total work done by all the forces is half m final speed square minus half m initial speed square. Change in the, basically this is delta k. This is nothing but delta k. Okay, that is one thing. And the second concept that I will use is work done is integration of the force with respect to the displacement from the initial position to the final position. That is how you can find the total work done by the net force. Okay, so using these two concepts, can I do something over here? Definitely. Maybe I can see initially there was kinetic energy, finally there is no kinetic energy. So there is a change in the kinetic energy. Somehow find the work. I think my problem will be solved. But before doing that, just do one more thing, which is finding the frictional force. How much is that frictional force? Well, that frictional force will be mu into normal. Normal is mg, but mu itself is variable, which is a divided by r square and into mg. So that is your frictional force. Okay. So from this, we can find out that work done. We can find out that total work done by that friction from 1 meter to infinity. That will be given by integration of starting with 1, going to infinity. All these things, force is your AMG. Wow. AMG. Yes, some of you might be thrilled knowing that AMG name. Yep. Your AMG V12 turbo, AMG V8. Some of you might be lost in the dreams of AMG. Okay, if you know what I mean. Anyways, coming back over here, this will be nothing but dr. All right. So going over here, AMG can be brought outside the integration. All of them are constants. So it will be nothing but integral of r raised to minus 2 dr from 1 to infinity. So this will be AMG. Okay. R raised to minus 2 is integration is minus 1 by minus 1. So r raised to minus 1 by minus 1, and the limits are 1 to infinity. So this will become finally minus will come outside. So minus AMG, and here we'll have 1 by infinity first, minus 1 by 1 by 1, minus 1 by 1. 1 by infinity is 0. 1 by infinity is obviously 0. and this will be just 1 by 1 over here, or just minus 1, I can say. So this will become just AMG. Is that right? This will just become AMG. Wow, finally, Srinav and Covert Destroyer. Finally, I was thinking nobody will get that joke, or I would be very sad if nobody wrote Mercedes AMG. I'd be like, what a generation have we come to? Okay, thank God you guys kept the honor of this class. Okay, so coming back now to the work energy theorem. So the total work done is half m final velocity, which is 0, minus half m initial speed, which is v naught. V naught, is it given to us? Is V naught given to us by any chance? The initial is also outwards. No, we have to find out. Oh, sorry, we have to find that out. My bad. So the total work done was nothing but AMG only. So just put AMG over here is equal to half m V naught square. Perfect. MM cancels. So AG multiplied by 2 goes on the top is V naught square. So V naught is root 2 AG. Wow. Root of 2 times of AG. That is what the answer will be. Root of 2 times of AG. Beautiful question with a nice creative framing of the problem. But actually, these circles and all of that were not so relevant for our problem solving so much. You just had to see, okay, at this point, this was the speed. At infinity, the speed was 0. So from here to here, friction will keep on changing and doing work. So the work done by that variable friction, the work done by that variable friction can be found via integration. And then that work done, I've just equated it to change in the kinetic energy. Is that okay, everyone? Beautiful. All right. Oh, we are going to get in a debate then. BMW versus Audi versus Mercedes in that league. Now, don't compare Porsche and Bentley and Aston Martin in this range. Obviously, they are much more superior. Okay, perfect. Going to the next question, guys, on your screen. A small block slides with the velocity of 0.5 root gr, 0.5 root gr on the horizontal frictionless surface as shown in the figure. Okay, the block leaves the surface at point C. The angle theta will be what? Okay, it is leaving that surface. Anytime anything leaves the surface means the normal force has become 0. Number one. Number two concept, by the time it reaches C, because it loses some potential energy, that will be converted into kinetic energy. So we have to do that part also. So let's just think about this diagram like this. Mm, This is the normal. This is that. This is that block over here. Obviously, it will have some velocity like this. To find that out, let me drop a horizontal like this. And I know that this much will be, I think the radius is given. Yes, it is R. So if the radius is given to be R, this much, because this is theta, because this is theta, this is theta. This will be nothing but r cos theta, and we all know this complete thing is r. So therefore, only this much r minus r cos theta, r minus r cos theta, which is r brackets 1 minus cos theta. This is basically the height by which it has fallen down. Remember that same thing over here. When it was here, it had some bare minimum velocity. How much velocity it had? 0.5 times root gr. So it was root gr the whole thing, root gr the whole thing divided by 2. Yeah, that was the initial velocity. So by the time it reached here, it has some new velocity which I do not know. But I know one more thing at that point is that the normal force will be 0. There will be mg components over here also. So how much will this be? This is theta. So if this was your mg, if this is theta, obviously this will be theta. Parallel lines intercept. This is theta. This is also theta. Alternate angles. So this will be how much? Mg sine theta. This will be mg cos theta. And the last thing, there will be also centripetal acceleration, which is AC. Now, if you look at in the normal direction, you will see that mg's cos theta minus the normal force is mass times centripetal, centripetal being v square by r. This will be still mg cos theta. Normal will be 0. So mm cancels. So v square will be rg cos theta. So that is the value of v square. R goes on the top, g cos theta, has got cancelled. Centripetal, this is basically Newton's law. Net force is mass into acceleration. In this direction, mg cos theta is in the direction of acceleration. Normal is opposite, so that's why minus n. But it has to lose contact. This n is equal to 0 is because it has to lose contact. It has to lose contact. That is the only reason for that. Cool. Now let's use energy conservation. Now let's use energy conservation. Energy conservation. Initially, it had potential energy, which was mgh, plus some kinetic energy, which was half m, velocity, which is root gr, the whole thing by 2 whole square. Finally, came down to this level, which is 0 energy, plus half m, your velocity square. Okay, so m gets cancelled. So g into h was nothing but from here r into 1 minus cos theta. Sorry, plus m has got cancelled. So 1 by 2 is there. Root gr square is gr. 2 square is 4 plus, no, not plus, is equal to m got cancelled. V square by 2. V square is rg cos theta. Rg cos theta. Multiply by 8 on both sides, or basically cancel gr everywhere. Just cancel gr everywhere. That will be better now. So 1 minus cos theta plus 1 by 8 is equal to 1 by 2 into cos theta. Okay. So take cos theta there. So I'll have 1 plus 1 by 8 is equal to cos theta plus half cos theta. That's it, guys. I think few steps more will get the answer. Yeah, 8 plus 1, that is 9. 9 by 8 is equal to 3 by 2 cos theta. So 3 and 3 cancels. So it will become just 3. And here, what is this? This will become 4 is equal to cos theta. So therefore, theta will be cos inverse of 3 by 4. Cos inverse of 3 by 4, let's see. Yes, cos inverse of 3 by 4 is the correct answer. Amazing. So here we needed Newton's laws because it has to lose contact. Plus we needed the concept of centripetal acceleration because it is going in a circular path. Then we found this speed, substituted it in the energy equation. So I have done a lot of substitutions. If you notice, V is this, also this value, yeah, root gr by cos theta. And the height also we have substituted as r into 1 minus cos theta. All these things were needed. Is that okay, everyone? Okay, great. Malikananda, you have amazing teachers in the crash course, my dear. So, I mean, obviously, like I said also, that there will be a team of teachers who are already teaching in the pro batch who will be there in the JEE crash course, right? Because I can't be there every time, everywhere. So, that's the reason why we have so many teachers, or else then I should be running the entire South India Institute then, okay? Or two, three teachers only then should run the whole show. That is not possible, right, dear? So, I hope you understand because of our limitations. So we try to be there in as many places as possible because you love us, but at the same time, our teachers everywhere are good. Now you can ask, sir, why is that teacher not here? Why is this teacher not there? I mean, you can ask endless, countless question. It is never ending discussion there. Cool. Yeah. Right. Next 10 days, uh, you can definitely try to push it. It's little hard, but you can definitely push it. the free body diagram. Okay, see how it works. This was that curvature. This was that normal, right? This was that mass. So technically that mg would come here, correct? And it was also mentioned this was theta. If this was theta, then what will happen? This will be theta because two parallel lines, this is the intercept. So mg will have two components. What will this be? Mg cos theta. This will be perpendicular to that. So this will be mg sin theta. It is kept on the surface, so there will be a normal force. It is going in a circular path. So towards the center, there will be centripetal acceleration. So that is why using net force is equal to mass into centripetal acceleration. This force will be this minus this, because whatever is the direction of acceleration should be taken as positive. So this will be positive. Obviously, this will be negative. Okay. So that's why mg cos helps in acceleration, normal opposes, but anyways, it is 0 in the step. Is that free body diagram absolutely clear? Yep. Covered. 84 percentile, how will it be okay? First, you have to clear JEE mains, right? So that's the reason why there is a cutoff. Okay. Let's go to the next kind of questions where center of mass, impact, impulse, collisions, momentum conservation, all these kind of questions might come. So there are brilliant questions which are coming up with amazing concepts. So let's go, guys. Here is the first question on your screen. There is a mass diameter sliding back and forth with some velocity on a wire between two rigid walls. Assume that the collisions with the walls are perfectly elastic and there is no friction. The average force of the bouncing bead exerts on one of the walls is how much? Whenever those questions on average forces comes, remember the average force can be found by many of these ways. First is integral force with respect to time from 0 to t, the whole thing divided by t. Or you can also use the total impulse divided by the total time interval. That is one way. Now the impulse, do not forget, is nothing but the total change in momentum upon the time. So this is nothing but the formula for impulse, which is the change in the momentum. So these are multiple ways by which you can find the average force. Now, in this particular problem that you see, there is a bead which is going back and forth. This reminds me of the derivation of kinetic theory of gases, if you may recollect. The average force on the walls of a cube, and from that average force, you divide by the area to get the pressure. So, very similar in that sense. So, let us think of the diagram now. So, let's just say, okay, this is that particular length. Okay, so from here to here, that length is, let's say, L. This is basically your L, and there is a bead of certain diameter like this. It goes, it hits here. Let's say it comes like this, hits here and starts going like this. Obviously, it will reach the other side. It will do the same thing. It will hit here and collide elastically. So it has to rebound back with the same speed. Now, if you notice, the actual distance that the bead travels either way is not L. And the reason for that is the dimension of the bead. Yeah, the dimension of the bead. So just concentrate on the center to center distance from here to here. Center of the bead, how much is it going from here to here? Because that's the maximum distance any point on that bead will move. If the center moves this much, any point on the bead will move that much, and that's the maximum distance you can move, because after that, geometrically you are constrained. Your surface will touch the end and you cannot move further. So remember that this much is the radius, this much is also the radius, center to the end, center to the end. So the distance, effectively, effective distance of motion, effective distance of motion will be the total length which is there minus what? R into 2 times. R from here, R from here. So technically, R and R together will make the diameter. So hence the answer will be nothing but L minus 2R, which is nothing but the diameter. Is this clear? Effective distance of motion is L minus 2R. Twice the radius is the diameter itself. Great. Now what do you do next? What do you do next? See, if you want to find the average force, you need to find the total change in momentum and take the total time. You consider any one wall. Let's say, for example, this particular wall. Let's say you're considering this particular wall. Okay. There will be some change in momentum on that wall. So if you consider that particular wall, due to that wall, there will be change in momentum. Change in momentum, that change in momentum will be final momentum. Let's say if it is mv, initial momentum will be minus mv. So it will become 2 times of mv. That's the change in momentum due to a wall, any one side, on any side. But how much time does it take to change that momentum from once to the next collision to the next collision? You have to wait after a collision for the ball to reach here and come back. So the time taken is that total distance that you travel effectively upon time is distance by speed. Time is distance divided by speed. So you travel once L minus D and again L minus D. So into 2 divided by V. So one time L minus D, again L minus D. So total distance effectively that you have traveled is 2 times of L minus D divided by that speed. So obviously now finding that average force is way easy. So which is change in momentum divided by the time. Change in momentum is 2 mv. Time interval is V minus, sorry, not V minus D, L minus D into 2, the whole thing divided by V. Yes, is that right? But that is time. I have to put it below, my bad. So divided by L minus D into 2, whole thing divided by V. Okay, so 2 will cancel. So mv divided by L minus D, and that V will go on the top. So it will become mv square by L minus D. mv square into L minus D, which is option labeled A. Option labeled A. Got it, guys? Everyone? Cool? Awesome. Awesome. Great. Perfecto. Perfecto, guys. Perfecto. Let's go to the next question coming up on your screen. Here it is. Okay, so there is a shell hanging from the ceiling over here. There are 2 holes, one over here and one over here. And which of them are true if sand is poured from either side or removed from one of the side? Read the question carefully, guys. Sand is being poured or removed from one or two of the sides. What do you think will be the correct answer? Think. Well, over here, if you pour the sand, earlier the center of mass of only the shell will be here. This is the center of mass of that particular shell. If you pour a little bit of sand over here, then the center of mass of the sand will be here. This will be where the center of mass of that sand will be if it is partially filled. So the effective center of mass will be somewhere over here. The effective center of mass, total center of mass effectively will be somewhere over here. So just imagine which of these will be true. Just check. If the shell is completely filled with sand and it is open, the center of mass will fall initially. Makes sense. If it was completely filled and if you open it from below, what will happen? The center of mass will go down initially. Why? Because the sand will go down. The center of mass of the sand will also go down. But once the sand empties that container, there is nothing. So the center of mass will again shift back to the center. So initially it will definitely fall. And when it is completely empty, again it has come back to its original state. So definitely option number B makes sense. It can't go up. Center of mass can't go up. Yes, Bombay, correct. Moving on to the next question. There are 2 people on the boat, opposite ends, boat's mass, length, everything given. If they interchange their position, what is the displacement of the center of mass of that boat? Beautiful question, guys. How much will the boat exactly move? That's the question. Hi, Abhinesh. Good afternoon. Whenever you get these kind of questions, these boatman questions, whenever you see center of mass is at rest, keep in mind there are couple of equations you will need. One, any one mass into its displacement, any second mass into its displacement, any third mass into its displacement. How many ever masses are there? The product of mass into displacement is zero, number one. This is the first concept. Sometimes you will also use the concept of relative displacement, which is displacement of 1 minus displacement of 2, or displacement of 2 minus displacement of 3, depending on whatever is given to you. So relative motion, V12 is V1 minus V2, V21 is V2 minus V1, S12 is S1 minus S2. So that relative motion will be needed. Okay. These are most probable questions. These are not VYQs. Okay. So now how do we do this? This is 1, this is 2, the boat is the third one. They are interchanging their positions. Okay. They are interchanging their positions. The displacement of the center of mass of the boat will be how much? Now, what will you do in the case of this? What will you do in the case of this? Come on, think about it. How much will it move by? See, first write down the basic equation. First mass 80 kilos into displacement 1 S1. Second mass, the other guy, which is 50 kilos. Displacement S2. Third mass of the boat, how much is it? 70. Displacement S3. The whole thing is 0. This is your first equation, but if you want, you can cancel 0, 0, 0. So it will become 8 times of S1 plus 5 times of S2 plus 7 times of S3 will be 0. This is my first equation. Now let me write down the second equation. If you think from the boat's perspective, from the frame of perspective of the boat, this person A has moved 2 meters towards the right. So displacement of A with respect to the boat is basically from this end to this end. So it is 2 meters. This is nothing but displacement of A, which is S1, minus displacement of boat, which is S3. So that is equal to 2. This is your second equation. S1 minus S3 is 2 because displacement of 1 with respect to the boat. Boat is labeled the mass 3. This is 1, this is 2. Keep that in mind. Same logic I can say displacement of B with respect to the boat. This guy, with respect to the boat, he goes here. So he's going to the left. So negative displacement of 2 meters. So this will be minus 2. So therefore, S2 minus S3 will be minus 2. S2 minus S3 will be minus 2. Is this absolutely clear? Now what will you do? Now what will you do? Three equations, three unknowns, solve them. So three equations, three unknowns, solve them. So solving this, you will get S1, you will get S2, you will also get S3. But I think the question asked is how much will the boat move by? You will get the value of S3. And after solving, I think you should get the answer as 30 towards the left. That means you should get the answer as minus 0.3 meters. So this negative means towards the left, and this tells me the magnitude, which is 30 centimeters. So solving these, you should get it. Three equations, three unknowns, solvable. Correct? Yeah. Yes, practicing these questions without any other things is a very, very good strategy, because obviously there are so many concepts in today's session. If you are able to grasp these concepts and solve it by yourself, you are already crossing that 99 percentile barrier level of thinking. So if you are able to solve these questions, trust me, they are good level questions. You are in the top 1 percentile. Okay, let's come to rotation. Lot of questions were there on rotation too. Yeah. And please don't think about taking a drop, beep, and all these things. Yeah, that is not needed. So after rotation and I think gravitation or something will be there. After this, we'll be taking a break and then we'll continue with the rest of the lecture. Okay. So don't worry. If you are hungry and waiting for the lunch to happen, just give me a few minutes. It will start. So let's start with rotation. A lot of questions you can see from rotation are asked in the January attempt. Correct. So let's see. Even questions on rolling were asked. So let's start with a question. A uniform rod length radially lies on a disc rotating about its axis. The rod does not slip and the center of the rod is at a distance r from the center. Then the kinetic energy of the rod is how much? Let's draw the disc first. This is that disc and this is the axis of the disc. Okay. There is a rod now which is given to us. Okay. The rod is lying somewhere over here. Okay. The rod of certain mass and length. And it is given to us that the center of the rod, which is exactly over here, is at a distance of r. So this is basically r. The length of the rod is L. The length of the rod is basically L. And the mass of the rod is also m. So this rod is having a mass of m. And this whole thing is rotating about this axis with angular speed omega. I feel this problem can be easily solved by a theorem which is your parallel or perpendicular axis theorem. If you remember, first thing, the moment of inertia about parallel axis is find the moment of inertia about center of mass, take the mass of the body and whatever amount you shift it by, square it. So this is your parallel axis theorem. Perpendicular axis theorem says you find the moment of inertia about two axes which are concurrent and in plane of that body. This is only for two-dimensional objects. You cannot use it for 3D objects. So I perpendicular is I1 plus I2. I1, I2, I perpendicular are all three perpendicular axes, out of which these two are in the plane of that two-dimensional object. The last thing that you will need in this problem is the kinetic energy of rotation is half moment of inertia multiplied by omega square. Half moment of inertia into omega square. These are the two concepts needed. As you can see, this rod's center of mass is here. So there is definitely a parallel axis forming over here. And this parallel axis will be I, center of mass, plus mass into the amount by which you have shifted it, the square. So that parallel axis will be moment of inertia of the rod has a formula ml square divided by 12. The shift is r from here to here or from here to here. So it will be m into r square. So if you want take m common, it will be L square by 12 plus r square. So that is the moment of inertia. But that's not the question. The question is find the kinetic energy of the rod. So the kinetic energy will be half moment of inertia into omega square. So it will be m by 2 into L square by 12 plus r square into this omega square. So there is only one option like that, as you can see, which is option A. M into half into omega square r square plus L square by 2. This is exactly this particular question option. Yep. M by 2 omega square r square plus L square by 2. 12. Cool. Yeah. Option A. Very good, Jarvis. Yes, Juko. Yes, Wisala. Thank you, I shoot so much. Yeah. The break will be easily for 20 minutes to 30 minutes. Don't worry. Yeah. You will have a long break. Okay. How about this question? There are two spheres, radius r by 2, mass m, and they're connected with a rod of length 2r. Okay, the two spheres, the rod of length 2r as shown in the figure. What will be the moment of inertia about an axis through the center of one of the spheres? Again, the usage of parallel axis theorem, guys. So we have to, let's say, find the moment of inertia about this particular axis. Okay, so first of this sphere and then of this sphere. So there are two spheres, accordingly we'll adjust. So the moment of inertia will be, first of all, if you just say I want the moment of inertia of only this particular sphere. It is just a sphere, the central axis, so it will be 2 by 5 mass into radius, which is r by 2 whole square. Now, similarly, if I want the moment of inertia about this sphere, about this axis, you have to shift the axis, that is also there. So, moment of inertia about center of mass, which is 2 by 5 m r by 2 whole square. This is moment of inertia about center of mass plus mass of the body, which is again m, into the shift. This is basically how much you are shifting it by from here to here. This was the center of mass. You're shifting it by 2r distance. So m into 2r whole square. That's it. Solve this and you will get the answer. I think you will get some big answer like 21 by 5 mr square. Just check it out. If you're getting it as 21 by 5 mr square. Just take the LCM, take mr square as common. You will get the factor as 21 by 5. So after the mains attempt, there will be number of things that we'll be doing on the channel. There are a couple of things like I want to be focused on. One is obviously JEE Advanced. A lot of students will be there. So some JEE Advanced sessions. Obviously VIT, EEE, AEEE, UGEE, all these tests, IIT exam for yeah your ISER, NISER, yeah, all these things, BitSat. So these things will be there. But don't expect many classes because obviously so many exams. If we keep doing, I think we will not be able to do it on the channel at the same time. So yeah, expect a couple of sessions, and plus last year's sessions are already there on the channel. You can make use of that as well. Yeah, a lot of mock tests, lot of practice sessions are there. Yeah. IIT also. I think I just mentioned IIT. Vidya. I just mentioned IIT. IIT also will do. See, all the top level exams like UGEE, IIT, or advanced, of course, and even BitSat for that matter, that will 100% happen on the channel because this is a proper JEE channel, guys. So we are focused on giving the quality content, the best college content for all the kids, so that every kid, no matter where you are, you should be able to achieve your dream. And lack of knowledge or lack of resources or lack of lecture should never be your concern. That we will always give you. Don't worry. Okay, cool. Let's go to the next question on your screen. Whoa, this is beautiful question, guys, because I can see some rough patch and some smooth patch. And the question is, if it rolls without slipping till B, and from there onwards, it basically has to slip because it is smooth. What is the ratio of the translational energy to rotational energy when you reach the point C? Beautiful question, guys. Yep, yep, beautiful question. Let's solve this. First of all, first of all, see over here. Let's say you have reached this particular point, okay, and then again you reach this particular point over here, okay. So at this place, you will have some speed, let's say v1. You will have some speed angular omega 1. But tell me, after B to C, won't the speed change? So it will definitely become v2 because it is smooth. So some loss of potential energy will definitely convert into kinetic. But because it is smooth, there will be no torque to rotate it further or to decelerate it further, to do anything, in fact, angular wise. So the angular velocity will not change. Believe me, this will still be omega 1. Yeah. So after point B, the angular speed won't change. It's only the linear speed which will change because of the mg sine theta component. Correct? Awesome. Perfect. Okay, perfect. Come on, guys, concentrate on the lecture. Yeah, concentrate on the class because this is the most intense class, guys. I'm telling you, lot of people are just practicing simple questions, and trust me, they will be in a shock when they see the paper set by NTA in April attempt, and they will be like, "Why the hell did my institute or teacher did not show me some good challenging questions to help my brain, think out of the box or to think of multiple concepts. These sessions, whatever we are doing on Vedantu J English channel, are one of the best and the finest sessions, I'm telling you, because we are giving you the quality content, we are giving you the top notch problems, and we are dedicated every day to give you 1 to 2 sessions. If it's a big session, we are keeping one because we want you to be focused on that subject that particular day. So make sure all of your friends who are serious are on this particular channel. Okay. So from here to here, let's say it comes down by certain height. Let's say from here to here, you come down by certain height. And again from here to here, again you come down by certain height. So first time I can say for the first time, the potential energy gravitational will be converted into half m v square, the translational energy, plus half I omega square. And the I value for this moment of inertia, what is it? Solid cylinder. So if it is a solid cylinder, it will be m r square by 2, and it comes without slipping, means omega will be v by r. So if omega is v by r, obviously, and you have to square it, this will be, so if you substitute it, it will be half m v1 square plus half moment of inertia is m r square by 2, velocity is v square by r square. Okay, r square cancels, so it will be half m v1 square plus 1 by 4 m v1 square. Yep. Now this is the translational part. This is the translational part. This is the rotational part of the energy. Anyways, we'll keep it aside. So therefore, mgh will be half plus 1/4, which is 3/4 m v1 square. Just check this out. 3 by 4, half plus 1/4 is 3 by 4. So mm cancels. So therefore, v1 square will be 4 by 3 gh. Perfect. Now let's go from here to here. So energy at B will be converted into energy at C. Now this energy at B has two parts. One is the potential energy, which is mgh as compared to this line. It also has kinetic energy, both of rotation and translation. Both of rotation and translation, both energies are there, which is nothing but mgh, which itself is nothing but mgh, because this, it has got it from A. From A, whatever potential energy was there was converted into kinetic energy. Okay. What is the energy at C? It has two parts. One is translation, one is rotation. Okay. Translation is half m v2 square. Rotation is half moment of inertia, uh, which is m r square. Oh, rotational energy will not change. Whatever rotational energy was here, it will still remain the same. So it will be still 1 by 4 m v1 square. It will still be the same, guys. It will not change because the omega will be the same. So that's it. This will become just 2 mgh will be nothing but half m v2 square plus 1/4 m v1 square, which is 4 by 3 gh. Okay, so 4 cancels. So you will get 2 mgh minus 1 by 3 mgh is equal to half m v2 square. Therefore, half m v2 square will be 2 3s are 6, 6 minus 1 is 5. So 5 by 3 mgh. 5 by 3 mgh. Now, what is this half mv square? This is nothing but the translational energy at C. Now, this rotational energy at B will be also the rotational energy at C. That's all. So, you have to find the ratio of translational energy at C upon rotational energy at C. Just take the ratio of the two. Translational energy at C is nothing but 5 by 3 mgh, and rotational energy at C is nothing but 1 by 4 m v1 square. So this v1 square we already know. Substitute it. Substitute it. What is it going to be substituted as? 4 by 3 gh. Substitute it and see if you will get the answer as the number 5. See if you get the answer as the number 5. Yeah, that's the answer. Is that okay? So it also tells us that if you make any kind of mistake, it's better to redo the problem rather than making the changes somewhere in between, because maybe it might affect other things. So better to redo the same problem. Cool. Great. Great. Yes. All right. Moving on to the next question. Okay, we are coming to gravitation. So let's do some questions on gravitational forces, escape speed, potential energy, satellites, etc. There are some amazing questions coming up. Let's have a look. The potential energy of a body is given by this. The magnitude of the acceleration of the body will be what? What concept is used here? Acceleration is asked. We know that acceleration is force by mass. I know the mass, but what is the force? Force is minus du by dr. Oh, so these are the two formulas which I will need. Force is related to the potential energy by this formula, and it is related to the acceleration by this formula. Okay, and this du by dr will also depend on, if you have some x component, y component, then take the partial derivative with respect to x, I cap, then take the partial derivative with respect to y, and then j cap, and same thing, partial derivative with respect to z, and then there is k cap with that minus sign. So I feel we should take the partial derivative because it is a function of x and y both. So our force will be minus derivative with respect to x of ax plus by minus partial derivative with respect to y of same thing ax plus by with a minus sign. Remember, this minus sign is there. This minus sign is there. Okay. So when I differentiate with x, y is a constant, by will be a constant. So derivative of a constant will be 0. So it will be just minus a, derivative of x will be 1, minus, when I differentiate with y, x is a constant, so constant's derivative is 0. So minus b, derivative of y is 1. So it will be nothing but, this will be I cap, this will be j cap, by the way. This is I cap and this will be j cap. So this will be minus a I cap minus b j cap. That is your force vector. So the magnitude of that force will be root of a square plus b square. But the question is something else, finding the acceleration. Acceleration is that force divided by mass. Force is root a square plus b square. The whole thing divided by the mass will be the acceleration. So I believe it is answer C, which is root a square plus b square, the whole thing divided by the mass. Nice question. Yeah, C for Captain Shreyas. Very good. Perfect, perfect, perfect. Great. Moving on. Moving on to the next question on your screen. A body of certain mass is at 4 times the radius of the Earth distance from the surface. How much is the energy so that it will escape? How much is the minimum energy required so that it escapes? So think like this. This is 4 times of R. This is where that mass is. This is the radius. Okay. I want it to escape, so I want to give it some energy. I know that if it reaches infinity, then the total energy will be 0. So at this moment, what is the energy of that mass? The energy of the mass at, at 4r from the surface. What is it? It is the kinetic energy and the potential energy. Kinetic, it is not there, it is just situated. It is just situated. Situated means it is definitely at rest. Potential wise, minus gmm divided by total distance will be r plus 4r, which will make it minus gm into m divided by 5r. Deliberately I did this because negative gm. Now there is a concept over here that our acceleration due to gravity on the surface is gm by r square. Therefore, small g r square is capital GM. Many times you can substitute this for this. So use that substitution over here. So instead of GM, write it as GR square. Rest of the things are as it is. This is small m divided by 5 times of R. So this will be, how much? RR cancels. Minus mgr divided by 5. Now, this energy will be equal to or plus some extra energy that you will give to escape it. will be the energy at infinity. Will be the energy at infinity. We know that the energy at infinity is zero. So therefore, that energy which is needed to escape it, the energy which is needed to escape it will be nothing but mgr divided by 5. Will be nothing but mgr divided by 5, which is C option. Which is C option. This was the energy by that mass at that location. If you give some extra energy, it will reach that infinity where the total energy is zero. So this will be, take it on the other side, it will become plus 5 mgr by 5. Is that right, everyone? Okay. Yes, again C for Captain Shreyas. Perfect. Amazing, amazing. Great. Let's move to the next question on your screen. Here it is. The energy graph versus the kinetic and potential energy graph are given for different distances or different locations A, B, C, and D. Where do you think the system is bound? Now you will see that be it modern physics, atomic structure, or satellites, the total energy of a satellite is minus gmm by 2r. The energy of an electron inside a Bohr's model is minus 13.6 electron volt at the ground state. So always these energies are negative. The negative energies always mean that the particular object or the particle or the system is bound to it. That means it is in a relationship. So whenever you see the total energy is negative, that means it's a committed relationship. You are bound. If that nucleus is there, the champa is there, the pandu is bound to the champa. The pandu can't leave champa and go. If the energy is zero or more than zero, that means it is like a free electron, free satellites, free mass. It's broken up or it's single. Champa can't demand, oh, you have to be with me. Pandu is like, sorry, boss, my total energy is more than zero. I am free. I can go wherever I want. So binding energy or bound system means the energy totally will be lesser than zero. Is that absolutely clear? Okay. So binding energy means it has to have a total energy. It has to have a total energy which is less than zero. Now this total energy means kinetic plus potential should be less than zero. Okay. Now kinetic energy is always positive. What does this tell you? What does this tell you? Kinetic energy is always going to be positive. Half mv square. Mass is never negative. That means the potential energy should be more negative. That means potential energy is more negative than the positivity of that kinetic energy. Got it? Is this absolutely clear? Only then the total energy will be negative. Great. So now observe over here. You will immediately understand that at point A, this is the kinetic energy. This is the potential energy. Okay, this is the kinetic energy. This is the potential energy. It looks okay from this particular graph. Can you see this distance is small? Can you see this distance is small and this distance is slightly big everywhere. This is small, this is slightly big. Can you see that? It's a minor difference, but that is what it is, guys. I hope you are able to see that. It's a small difference. So everywhere, potential energy is more than the kinetic energy. That means all the points A, B, C, and D. Actually, this graph should have been drawn properly. I mean, it's not so obvious. The actual graph should have looked like this. The actual graph should have looked like this. This is kinetic energy. This is potential energy. This is kinetic, this is potential. So this point, this point, this point, this point, everywhere potential energy is more negative. Remember, this is more negative. This is positive. So hence all the points are going to be bound. Hence all the points are going to be bound to it. Is this absolutely clear? A, B, C, and D? Yeah. So you have to, yeah, expand that graph a little bit to see that difference. I mean, the difference is not so clear in the NTA exam. Obviously, this has to be more crisp and clear, or else this will become a bonus question. Okay, so I am telling this to you because these questions are now discussed here, that this has to be smaller, this has to be more negative. Cool. Okay, I hope SV that is absolutely clear. Let's go to the next question. A particle is projected with some speed. Find the maximum height reached from the surface. This is standard question, guys. There is a surface. You throw the particle with some speed, root gr, I believe. It will go up till some height, h, and it will stop. The question is, what is this height? Remember, this same thing is at a distance r from the center of the earth. This is the surface. So use energy conservation. Conserve energy. That's all. Conserve energy. At the surface, there is a potential energy of gmm by r. There is no kinetic energy. Sorry, there is kinetic energy, which is half m v. V is root gr square. This was your potential energy. This was your kinetic energy, all at the surface. When you reach on the top, you stop. This is at the topmost position, kinetic energy. And there is potential energy of minus gmm by r plus h. This is your potential energy at the top. Okay, so let's see what happens. Oh, okay, minus gmm by r plus m r and 2, and this is small g. Small g is gm by r square. This is basically the value of small g, okay, which I have substituted over here. mr by 2 and small g is gm by r square is equal to minus gmm by r plus h. Gmm will get cancelled. R got cancelled over here. Okay, so we are left with minus 1 by r is equal to, what do we have? Sorry, not is equal to, plus 1 by 2 times of r is equal to minus 1 by r plus h. So this is minus 1 by r plus half, which is minus 1 by 2r is equal to minus 1 by r plus h. Multiply by negative and take the reciprocal. So it will become 2r is equal to r plus h. So therefore, h is equal to 2r minus r. Therefore, h is equal to r. So the answer will be the radius itself. The answer will be the radius itself. So it goes till a height of r. Do not use kinematics in such questions. Don't use kinematic equation since acceleration is not constant. Kinematic equations are only applicable when acceleration due to gravity is a constant value, or else you cannot use it. Yeah. Yeah. I think somebody asked it. Oh my God, Gauri, you already asked that out, huh? Okay. So that is the reason for it. You have to go to energy conservation. So these kind of questions are often there, and many times people make that mistake out there. Okay, don't worry. Let's do the next question. Satellite is in an orbit. At some point, impulse is given so that the velocity increases n times. Now it goes into elliptical orbit. What is the maximum possible value of that velocity? Okay. See, this is that planet. There is a satellite which is going very close to it, like this. This is the orbit. Now, this satellite is going very close to the surface, going like this in a circular orbit. If it has to escape, that means it has to go in a path like this. If it doesn't escape, then what will happen? It will probably go in an elliptical orbit like this. If you give it more velocity, maybe it will go in a bigger ellipse like this, but it will still be bound to that planet. In this case, it will escape, and we know that the escape velocity is the root of 2 times of gm by r, which is root 2 times root gm by r. which is root 2 times the velocity in that particular orbit, which is velocity in that particular orbit. So this is the escape speed. It is root 2 times of that. So the maximum possible value of that velocity will be root 2 times that original velocity. If it has to escape, if it shouldn't escape, if it has to be in some kind of orbit, obviously the velocity in that orbit has to be lesser than or equal to, or I would say lesser than root 2 times of that old velocity. So hence you can see, because the velocity has to be less than root 2 times, the maximum possible value will be root 2. You can't go beyond root 2, then it will escape that particular planet's gravity. Yeah. I hope this is absolutely clear. Yeah. Cool. Let's go ahead to some last thing before we break. Okay, I think, okay, we'll break it now only and then we'll return. Okay, because or else it will take a long time to discuss those things. We'll take a break and we'll return shortly. Okay, we'll take a half an hour break, right? We'll take a half an hour break. Welcome aboard. Welcome back. Welcome back. Gather everyone around. Yeah, the break time is over. We had a decent break for your lunch, and hopefully you are all fresh and energetic. Quickly let me know in the chat box. All my dear students, see, the enthusiasm usually dies out whenever there are big marathons and students give up easily than the teachers. It's surprising that actually I don't have to give any exam. You have to give the exam. So guys, you need this marathon more than me. Let me tell you that. So please gather yourself up, push yourself, even if you feel that you cannot do it, lie to yourself that I will do it, and make sure you attempt each and every single question which is done here. Because we are doing lots of questions with the concepts related to that and seeing how exactly those formulas and those theory are applied on the problems practically. So let's gather ourselves, guys. Quickly join in the session. I want, yep, the attendance to go up quickly. Yep, and let's make this 500 likes. What are you guys doing? And by the end of the session, this should be easily 1000 likes. If you are not doing that, I will understand JEE English students are not serious, which will be a very bad day. Okay, so let's do this, guys. Come on. Okay, let's go. Yeah, very good afternoon, Gauri, Sanjay, Jan, Joseph, Anshu, Rakesh. Welcome, Anshu. I will do it. Very good, very good. Let's begin with the class, guys. And some questions coming up from mechanical properties of fluids and solids. This had a lot of important questions. Let me tell you that. Yep, so many questions were there on this, and lot of people thought this is like an optional chapter or what. No, but it is not. All right. So let's begin with this particular question coming up on your screen. The diagram shows a soap film in which a closed thread is lying. The film inside the thread is pricked. Now the sliding wire is moved out so that the surface area increases. The radius of the circle formed by the thread will what? See, over here, there is a film, there is a thread, you prick it, what will happen? The film will now be existent only in this particular region. It will be existent only in this particular region. But even then, the circumference of this will be the same. So very important, the circumference will remain the same. That means the force of surface tension acts on the same length, acts on the same length. Nothing will happen. So if the force of surface tension acts on the same length, therefore, what should happen? There should be no change in length. Therefore, there should be no change in that particular loop. There is no change in the force, there is no change in the length, there is no change in the loop size itself. So hence it will remain the same. That is the correct answer for this. Is that right? Everyone? Amazing. Proud of all of you if you're given the right answer. Let's move ahead. Yep, let's move ahead. And by the way, some students had also asked me, sir, can you tell me about that equivalent spring constant for rods and all that? Let me tell you that also. See, sometimes you might be given questions where there might be a rod and you might have to convert it into a spring for whatever reasons. Maybe the rods are in series, or you have connected a mass and hit the rod, so it vibrates. So you treat it like a spring mass system. So remember, if the Young's modulus is Y, length of it is L, this is area of cross section. This particular equivalent spring constant can be found out like this. I will make you remember the formula also. See, Young's modulus is nothing but force divided by area, extension divided by original length. Rearranging it, it will become y into x by L is f by a. So therefore, f will be equal to y a by L multiplied by x. Since force is proportional to x, this is like f is kx. So hence the equivalent spring constant is basically Young's modulus into area divided by the length. Ya by L is the equivalent spring constant, which will be useful in certain cases. Okay, so please remember this formula definitely. And one more formula where students get confused is this energy density rho u, which is half strain into stress. Half strain into stress. This particular thing is the energy stored per unit volume. Okay, so this is nothing but the energy stored in a stretched rod or something. This is your strain, which is change in length by original length. This is stress, which is force per unit area. And obviously, stress by strain is our modulus of elasticity. So this is for stress and strain when multiplied by half gives you energy per unit volume, not just the energy. These are the two most commonly confused formulas. Okay. Anyways, let's go ahead to the next question. This was remain same, of course. Let's go to the next one coming up on your screen. Okay. Yeah, it can also do SHM like that rod when it is hit, it will do SHM just like a spring mass system. So there you can use 2 pi under root m by k, where k is that equivalent spring constant. There is a water which is coming out of the mouth of a tap and it is going in a streamline flow. It forms a tapering. Tapering means the cross section is changing. And what is the reason for that? What is the reason for that? The water moves down, the speed increases, hence pressure decreases. Water tries to reach the terminal speed, hence area decreases. Mass of the water must remain same. Also, water is incompressible, hence the rate of volume flow must remain constant. So, which is area into velocity, thus the area decreases. Surface tension causes the surface of the water to decrease continuously. This is straightforward. See, when you are at the top cross section, if there is certain speed, let's say this is that area, when you go down, because there is, as you go down, there is loss of potential energy, which will be converted into the kinetic energy which has been gained. So the speed should increase. If speed increases, if the speed is more, what will happen? The area of cross section should be less, because we know that is how it works. A prime V prime will be equal to capital AV, which is the equation of continuity. So the equation of continuity is there in option C. Yep, this is the formula, area into velocity. Remember, there are two formulas. One is the volume flowing per unit time, which is nothing but area into velocity. But if it is the mass flowing per unit time, then you multiplied by rho AV. Rho AV. Yep. So that's what you multiply to get the mass flowing per unit time. Because density is same, so then it becomes area into velocity on both sides, because even if you put density, it will get cancelled because it is incompressible. And that is what you assume as an ideal fluid to be. Yeah, the ideal fluid is always assumed to be incompressible, irrotational, non-viscous, streamline flow, which is exactly the given statements of this problem. Yeah. Shall we go ahead? The session PDF will be available after some time, not immediately. It will take some time because all of this has to be compiled and all of that. Don't worry. Moving on to the next question. There is a sealed tank and liquid of density rho is there and it has some horizontal acceleration. What is the pressure difference between the 2 points? Now, in such questions, the logic is as follows. If there is acceleration due to gravity in one place, then you will see isobars are formed perpendicular to it. That means this is an isobar, means the pressure is same at all these points. Okay. And as you go from this point to this point, the pressure increases. The amount by which the pressure increases in the direction of gravity is given by rho, density of the fluid, into gravity into the distance between them. This is h, rho g h. So basically, pressure increases in direction of the gravity, Okay, let's come back over here. In this particular problem, there are two different points in two different places. So if you consider this horizontal line versus this horizontal line, the pressure at point B is more than the pressure at point C by an amount given by density into acceleration due to gravity is there downwards like this, which is g. So g into basically that height difference, which is h. So pressure at B is more than pressure of C for sure. There is no doubt about it. But same way, because this chamber is accelerating towards the right, do not forget there will be a pseudo force here and there will be a pseudo gravity in the left side. Because the chamber is going right side, everything will be pushed back here and that gravity will be here, because of which if you drop lines perpendicular to them, you will see this versus this. Obviously, C will be higher than at A. C's pressure will be more than at A. So pressure of C minus pressure of A will be again density, but that acceleration will be A, and the difference between those two levels is nothing but L. Now, all you need to do is add both of them, you will get the answer. All you need to do is add both of them. So it will become PB, PC will cancel, minus PA is equal to rho, and then what is it? GH plus A into L. GH plus A into L, which is D option, of course. D option. So in this particular question, there were two directions which you need to consider separately. Pressure variations with height are because of gravity. Pressure variations with the width are because of the chamber being accelerated. If the chamber was not accelerated, C and A would definitely have the same pressure. There is no doubt. Only because of that acceleration, pseudo gravity will come here. Remember, pseudo force is ma, so gravity will be divided by mass. So A will be the gravitational acceleration in the horizontal direction. So treat it like gravity only. Instead of G, think of it like A. Okay, that's all. Is that all right, everyone? Give me a thumbs up if you understood this particular question. It was a brilliant, brilliant question, guys. Let's move. Two very wide parallel glass plates are held vertically with a small separation dipped in water. Some water will climb up in the gap between the plates. Let S be the surface tension of water and P be the atmospheric pressure of water just below. Then what is the pressure difference given by? Now, the moment you look at this question, you will think, sir, pressure difference between concave convex surface, isn't it 2S by R? But that's okay if it was a spherical surface. Here, these two plates are there. The surface which is there, it is not spherical, it is like cylindrical surface. It's like your gutter which is there on the side of the road. This is like gutter which is there, like a groove, like a small groove in which something can slide. So you have to think little bit differently in this particular problem. I'll tell you how. See, there are multiple concepts here. First concept is, if you have any curved surface and let's say you have any, let's say, curved surface like this, and let's say on that there is pressure which is acting like this. There is pressure which is acting like this. If you want to find the net force due to the pressure on the curved surface, all you do is just take the projected area. That means the rays of light, if they were parallel to this curved surface, how much shadow they will cast. That is basically the projected area. So let's say the projected area is this much. So imagine the rays of light going like this, and they are casting a shadow of this much. So this is called as the projected area. Projected area. Then the force on the curved surface is exactly the force on the projected area with the same pressure, which is the same pressure multiplied by the area of that particular projection, multiplied by the area of the projection. This is one of the first important principles that you will be needing for solving this problem. Okay. Next important thing, we know surface tension is a force which is acting along the surface of the liquid, which is the force per unit length. So we'll need that. So in this particular diagram, I will say I can redraw it like this. Observe. Okay. So this was how it was. And this is how that liquid surface was, isn't it? Maybe it was like this. Okay. I can't see it properly because some part will be hidden, of course. So it will go like this. Okay. Now just consider this particular cross section, and in that you will see very quickly that entirely along this length, the force of surface tension will start pulling it like this. The force of surface tension will start pulling it up like this, as well as over here, which is now hidden. I cannot see it very clearly, but it is definitely there. Right from here, like this. It is there. This is the force of surface tension which is there, acting upwards. Now, this particular force of surface tension will be the length multiplied by the surface tension value, which is basically T. So, this length and this length, how much will it be, guys? Come on, let's assume it as L, but there are two sides, so L plus L into T, which is basically 2LT. This is the net force of surface tension acting upwards, correct? Okay. Now do not forget, pressure is acting from the top like this. Pressure is acting from the top like this, which is P naught. And there is also pressure of the liquid from below like this. Let's say I call it P. So the force from the top, which is there on the curved surface, will be the force on the flat surface. Now, how will that flat surface, which is the projected surface, look like? It will look like a rectangle. It will look exactly like a rectangle. That will be the projected area. Observe it carefully. That's how the projected area will look like. Yep. This is your projected area. Can you understand this? This is your projected area of that curved surface. If light were to go like that, the shadow that will be cast will be a rectangle. So now think of it as if there is pressure which is coming from the top, pressure which is coming from below. So these are the two pressures. So the force will be nothing but the pressure multiplied by the area. Well, this is having some length L, this is having some thickness T. So P naught into how much? Area. Area is nothing but L into T. Similarly, the force from below will be this pressure multiplied by that area of projection, which is again L into T. That's it. Now all the forces must balance each other out. All the forces must balance each other out. So to balance each other out, whatever force is acting upwards, let me write it first. This force is acting upwards, so PLT plus one more force is acting upwards, which is 2LT, but that is not thickness, that is surface tension. Do not confuse with this T. One force is acting downwards, which is P naught L into T. Okay, L gets cancelled. So I am left with P minus P naught. The whole thing multiplied by the thickness is nothing but, or P naught minus P, I can write it as, I can put 2L in, sorry, L has got cancelled. 2T will be equal to what? This will become P naught T minus P into T. Perfect. So therefore, from this, P naught minus P will be equal to 2T by the thickness. Yes, 2T by that particular thickness. Is this clear, guys? Is this clear, guys? 2 into, this is surface tension divided by the thickness, or basically the distance between the two slabs. This is basically your T. This was basically your T. Yeah. That is small t. This is surface tension. So hence, I think it will be 2T by R. Correct. Perfect. Awesome. Everyone clear? Understood how to solve this? This concept was very important, guys. Force on a curved surface is the same as the force on a projected area. If you know that, it will help you solve many questions. Next one. When you dip a capillary in some liquid, it rises till some height and there is some energy. If it is dipped in a liquid of height, sorry, radius 2r, then what is the new potential energy ratio as compared to the old one? Okay, let's see. How do we do this? Potential energy of that liquid which is going to rise. Potential energy of that liquid which is going to rise in that particular water. Okay, let's say it goes up till here. So this is the amount of water which will be there. This is height h. This will be having a circular cross section. So the center of mass of that entire thing will be somewhere over here. So we will need it. We will need it for potential energy calculation. This is at a height of h by 2. So in general, the potential energy which is there, U, will be given by m, the total mass, into g into the height, which is h by 2. Mass, let me write it as, okay, density into area into the height, rho a into height. That's the volume, of course. That's the volume. Density into volume is mass. This into g into h divided by 2. So this will become rho into area is pi r square into g, the whole thing divided by 2. H into h is h square. H into h is h square. Now this will become very interesting. Rho pi r square g by 2. Height rise by a capillary tube. Height rise by a capillary tube. What's the formula? It was 2s cos theta by rho g r. Correct? Rho g r. But this will be whole squared. The best part will be r and r will get cancelled. This is squared. This is also squared. So it will be a constant, guys. It will be independent of r. It will be independent. It will be independent of small r, because r square and r square will get cancelled. So if that's the case, this 2r has no meaning in it. So the ratio should be 1:1. So u1 by u2 should be the same. So 1:1 should be the answer, which is D option. You just had to derive this till this point where you understand it is independent. You don't have to get the exact formula till this point. If you do it, it's perfectly okay. Very good, Rajmani. Awesomeness. Excellent. Excelente, guys. Excelente. All right. Let's move ahead to the next question. Coming up on your screen, here it is. A cylindrical vessel filled with water is released on an inclined surface as shown. It's smooth. The the incline will be then the constant angle made by the surface of water. The surface of the water will make some angle with the inclination. How much angle will it make? Okay, how much angle will it make when it is sliding down? Assume the surface is smooth because nothing else is given to us. Let's think. Let's think, guys. See, one thing you should know. wherever the acceleration due to gravity effectively comes out. Let's say this is G effective. When I say G effective, it means it is the vector sum of G plus A. This is your actual gravity which is there. This comes because the frame is accelerated. So sometimes also called as the pseudo gravity. So wherever the net gravity comes, the surface of the fluid is always perpendicular to that. This is the surface of the fluid. This is the concept which is involved. Cool? Okay. Now, how do we do that over here? Well, we know this particular tumbler is definitely going to go down with some acceleration down like this. And that acceleration is nothing but g sine of theta. So for that tumbler, which is there, for that tumbler which is there is one acceleration because of which there will be one pseudo acceleration or pseudo gravity. So the pseudo acceleration, will be exactly opposite. It will be g sine theta. And there will be one actual acceleration which will be g like this. This is actual gravity. But this actual gravity also I can split it up into two parts, isn't it? One like this and the other one like this. This being theta always. So this is g cos theta. This will be your g sine theta. All this has been actual and I have split it off. I have resolved it into two components. The best part when I resolve it into two components is that you will notice that this g sine theta and this g sine theta end up cancelling out each other, which means that tumbler which is there, that mug, container, whatever is there, the only resultant gravity which remains is exactly this. This is your G effective. So whatever surface is there of that liquid should be perpendicular to that. This is the surface of the fluid always. So this is how it will be. Now the question is how much angle will it make with the inclination? Well, the inclination, the surface, this is your inclined plane. This is your inclined plane. Obviously, the surface is parallel to that inclined plane. So the surface is making 0 degrees with that inclined plane because they are both parallel to each other. Hence, the answer should be basically 0. Yes, you can see the answer is 0 degrees. Is this absolutely clear, guys? A lot of people think it should be tan theta, some tan inverse of A by G, God knows whatever. No height is required, nothing is required, just simple visualization of pseudo gravity, actual gravity, split up, forces, accelerations cancel. So the net gravity is this way. It has to be perpendicular, which is then parallel to the inclined surface directly. Isn't it fascinating? Cool. Let's go, guys, to the next question coming up on your screen. And this is on heat and thermodynamics. Again, you can see around 6, and then you had 6, and then 5. That's crazy amount of questions which were asked in January attempt. So obviously, again, very, very high weightage. So you will see a lot of questions which I'll be asking over here on thermodynamics. Starting off with the first one, the graph shows a plot of the temperature in Celsius and Fahrenheit. This is Celsius and this is Fahrenheit. The question is about the slope of that line. What do you think is the slope of that line? Celsius versus Fahrenheit. Celsius versus Fahrenheit. Come on. You should be able to get it. Is it A, B, C, or D? I want everybody to spam the answer. Let's see whether you can get it here. It's not that difficult. Come on. Figure this out. Let me just drink some water. Okay, guys. Yep. So if you have something in Fahrenheit, subtract 32 from it, multiply 5 by 9, and that will give you the Celsius. Okay, so this is y-axis, this is x-axis. So basically, if you find dc by df, dc by df, differentiate with respect to f, this will be 5 by 9 into 1, and this is a constant, so 0. So this will be basically 5 by 9, which is dc by df, which is nothing but the slope of that graph. Yep, so the slope of that graph is 5 by 9. That is B for IIT Bombay. If you know this formula, it is very easy. Just remember one thing, that, see, these are basic things which you should know. The freezing point, the boiling point, so of water is 0 degrees Celsius, 100 degrees Celsius. In Kelvin, it is 273 Kelvin. This is 373 Kelvin. Here, this is 32 degree Fahrenheit, and this will be 212 degree Fahrenheit. So if you remember that, it becomes very easy. And also remember, if you go a little bit behind, say 0 and 32, 100 and 2 and 2, this will start becoming less. It is exactly at minus 40 degrees Celsius that they become equal in temperature and value. So this is when both these scales become one single value. Other all points, it will be showing you different values. Means 20 degrees Celsius will be something else in Fahrenheit, but only at minus 40 in degrees Celsius and degree Fahrenheit will be exactly the same temperature. That's where the scales coincide. So these special things you should definitely be aware of. Okay, we have some table, and the number of moles, the mass of the molecules, individual atoms, RMS speeds and temperatures are given. The question is, which of the correct relationships is going to be true? Okay, so the logic for this, I feel, is RMS value, remember, is root of 3RT by M. The average value, remember, is 8RT by pi into M, and the most probable value is root 2RT by M. These were the three values, correct? So of speeds, but here we are interested in the RMS speed. So I think we will be sticking to only this particular formula. Now, when you stick to this particular formula for RMS speed, it only depends on temperature and the molar mass. Okay, fine. Monoatomic ideal gases. Okay, so guys, come on. Temperature, RMS speed, mass of those individual atoms, that will decide your molar mass, obviously. Oh, so number of moles has no role to play. How does number of moles do anything? This has no role only. This is a completely waste data. Do you guys agree with it? This is a completely waste data. So completely ignore these values. Ignore these values. Just concentrate on this. Mass of the molecule, if it is more, obviously their molar mass will also be more. So just compare, guys, for every one of them. I mean, in the first case, uh, what will happen? What will happen? See, it will be like V in the first case for A I'm talking about. This is for A. VRMS is the root of 3R TA divided by M, which is basically how much? 4M. So from this, TA will be root 4 is 2. So 2 times V square. Uh, V square M divided by 3R. M divided by 3R. So square both sides, that's what you will get. Similarly, do it for B, guys. Similarly, do it for B. It is 2 times, I think. So 2 times V is equal to root of 3R TB. Molar mass is nothing but M. So square both sides. So it will be TB is equal to 4V square into M by 3R. Similarly, do it for C. The speed is just V. So it will be V is equal to root of 3R TC divided by mass is 3M. So therefore TC will be V square and into 3, I believe. Yes, 3 uh, uh, V square into M divided by 3R. And lastly for D, same thing you do it. This will be nothing but 2 times V will be root of 3R TD divided by the molar mass, which is nothing but 2M. Therefore, your TD will be 4 square into 2 is, sorry, 2 square is 4, 4 into 2 is 8, 8 V square into M divided by 3R. Now it becomes easy to compare, guys. Now it basically becomes easy to compare. Is that right, everyone? Just check it out. Uh, Sorry, I had to square this and I think I made it 2, my bad. So when you square it, this will become 4V square, sorry. So I think this number and this number will be equal, TA and TB. TD will be the highest, TC will be the lowest. Yes, TC is the minimum. Correct. So answer C should be correct. Yep, it is definitely equal. From this, you can easily see B and A are equal, 4V square, 4V square, perfect. This is 3, which is the least, 8 is the highest number. So that is D. Perfect. Option C. Awesomeness. Let's go, guys. The area of cross section is given and it changes with the distance. The thermal conductivity is K. What is the thermal resistance of the rod? Beautiful question. All right. What will you do? Let's understand the concept. If you have a cross section like this, whose thickness is, let's say, dx, area is, let's say, A, temperature difference, let's say, is dt, then the heat flow rate dq by dt is given by Ka, temperature difference with respect to the distance, dt by dx. Also, there is a formula for something called as the thermal resistance. The thermal resistance is given by the length, which is this case dx, by k into A, which is here. So this is the small thermal resistance of that small element which is there. Remember, this is a part of a big thing, maybe like this. Yeah, this could be some random area of cross section which you have chosen, and heat is definitely flowing through it like this. Heat is flowing through it. So when heat flows, the rate of heat flow is this formula. The resistance by this small element is this much. These two concepts will be useful now. So you can convert thermal conductivity problems into resistance problems. This is that equivalent resistance. Now just imagine if the area of cross section was changing. Maybe it was like this. Chuma have taken something like that. Let's say the area of cross section is changing. So obviously, if you are here, the resistance is different. Here 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 the resistance is different. All these resistors are definitely in series. Different resistance in series. So when I convert it into an equivalent problem, I have to just add the resistance to find that equivalent. So their equivalent resistance will be R1 plus R2 plus like that Rn, but there will be infinite such resistances because there will be many such cross sections. So basically I can say it is integral of dr. This is nothing but the thermal resistance of a section. This is the thermal resistance of a section. So that will be nothing but integration of dr. Is that right? These are the concepts used, guys. Let's come back to our original problem and see what do we exactly have to do. The area is changing. Some constants are there. X is the distance. Conductivity is given. What is the thermal resistance of the rod's length is L naught. Okay, fair enough. So what I will do, I'll just say, you know what? See, this was that thing like this. Maybe you take one such section over here. This is having an area A is equal to, what is that formula? A naught 1 minus, sorry, 1 plus alpha x. A naught 1 plus alpha x. This is not your thermal coefficient and all of that. Some constant it is. So don't get confused. Okay. So thermal resistance dr, R is equal to L by K. So L over here will be dx, K into A, which is a dx divided by K into A naught into 1 plus alpha x. That is what it will be. Now, what is dx and everything over here? This is basically your dx, and from here to here, that is basically x, and the total length from here to here is, I think, L naught. That is what is given to us. All these are the things given to us. So let's now think, what do we do? I want to find the total thermal resistance, which will be integral dr as explained before. So dr is nothing but small width by thermal conductivity A naught 1 plus alpha x, of course. So 1 by k A naught will come over here. Integral dx will be there, 1 plus alpha x. X will start from here. This is 0 to the final length. So 0 to L. So this will be 1 by k A naught. This is 1 plus something x. Log x will be the integral value. So this will be ln 1 plus alpha x whole thing divided by alpha, and put the limits of 0 to L later on. Correct, guys? This is how the this is how integration will work. Whatever is multiplied with x will be divided now. Correct, everyone? Okay. So what will I get? 1 by k A naught alpha. This will be log of 1 plus alpha into L minus log of 1 plus alpha multiplied by 0. Okay, so log A minus log B is nothing but log A by B. So this will be log of 1 plus alpha L naught divided by 1, which is just this. So that's the answer. 1 plus K alpha naught, 1 plus alpha L naught, 1 plus alpha L naught. Perfect. This is the correct answer. Everyone got it? How to do this? Beautiful integration involved. And don't think such integration problems will not come. You saw that in the January attempt, there were many questions on integration as well. And that is only what is going to differentiate you from a top percentiler versus a low percentiler. Cool. Shall we go ahead? Loving the questions. Full josh, full momentum to be used now to solve the problems, guys. A thermodynamic system undergoes the cyclic process A, B, C, D, A. A, B, C, D, A. Okay. The question is, the work done in the system is how much? Work done by the system, sorry, is how much? Come on, my dear students, figure this out. What is the work done in this particular process? It's easy peasy, lemon squeezy. What should it be? Come on. I'll tell you, work done. The idea is find the area enclosed by that graph. This is the concept. If it is a cyclic process, and if it is a clockwise cycle, then this is considered as positive work for PV diagram. And if it is anti-clockwise cycle, then that particular area is considered to be negative work. It is considered to be negative work. Is that okay? So now coming back over here, as you can see, there is A, B, C. Actually, the arrow marks are wrong. A to B, B to C, C to D, D to A, and like this. Okay. So if you notice over here, this particular cyclic process, there is an anti-clockwise direction, so negative work, whereas this part of it is basically positive. Both of them are equal in areas. So therefore, if I count the total work, the amount of positivity and the amount of negativity will be equal. So it will become big fat 0. So D should be the correct answer. Yes, it is. They are equal because their heights are equal, their bases are equal. Those are congruent triangles. So they will cancel out their areas, clockwise and anti-clockwise. Yes, SV. Magic's that answer is correct. Yes, Dhananjayan. It is ready option. Perfecto. Moving on. 1 mole of an ideal gas. What kind is it? I think it was supposed to be given. It is monoatomic or something. I think monoatomic gas undergoes a cyclic process ACBA. ACBA. Okay. Process AC. Yep. This process is adiabatic. Temperature at A, B, C, R, blah, blah, blah. What is the internal energy change? 100% D option is wrong. Can somebody tell me why D option is wrong? Even without solving, you should be able to tell either it is A, B, or C. Either it is A, B, or C. How can you tell that? How can you tell that, guys? Yep. How can you tell that? Come on. Think. Because, yeah, it's a cyclic process. In a cyclic process, delta U, total internal energy, this cannot be plus 150. It has to be 0 joules. It has to be 0 joules. That will be correct. Yeah, perfect. Okay, it's not about positive. No, work is positive. Internal energy, it's coming back to the same state. It will be 0. Heat and work will be positive because it is clockwise. Otherwise, delta U for any cyclic processes are 0. Yeah, so here, no matter what it is, please keep in mind delta U is 0. It is the total work which is the heat. Yeah, this is what it is. This is only for cyclic process. Cyclic process. Okay, fine. So then let's do it one by one. Let's say we go from A to C. So delta U from A to C, the formula is NCV delta T. Number of moles 1, R, sorry, CV is 3R by 2. Delta T, C minus A. C minus A. So 450 minus 300, which is 3 by 2 R into 150. So this is 75. This will be 225. 225 R. Oh, by chance, my first answer only got me the answer. My first check only got it. Yep. No, Reet, it is not B. No, Dhananjayan, it is not B. Yes, Joseph, it is A option. That is the correct answer. If you find for everything else also, you can get it. It is not that difficult. It will not be correct. Let's say, for example, you find it from, say, B to A. So, the internal energy change from B to A. Number of moles 1, CV is 3R by 2. This B to A, this and this. So, A's temperature is 300. B's temperature is 600. So this will become 3R by 2 multiplied by 300, which is nothing but 150 into 3, which is 450, but with a negative sign, minus 450 into R. So this would have been minus 450 R. So definitely it is not correct, guys. This and this will be also wrong. You can check it. This will not be minus 225 R. Okay, got it? Why it is not B also? Yeah, it should have been minus 450. It is 150, which is definitely wrong. All right. Cool. Let's go to the next question on your screen. Next question on your screen. Let's try this out. So what do we have? Some moles of monodi nonlinear, okay, are mixed the equivalent degrees of freedom. Now, whenever such questions come, most of the students make a mistake. They think I can use N1, F1 plus N2, F2 plus N3, F3 upon N1 plus N2 plus N3, like the center of mass formula. But that is absolutely incorrect. Do not do such stupid things. Instead, think like this. What will be for mono the CV value and CP value? The CV value will be nothing but 3R by 2. For this guy, it will be 5R by 2. And for this guy, 6R by 2, which is 3R. Same thing for, I don't think CP is needed. Just find CV of the mixture. That's more than enough. So CV of the mixture will be N1 CV1 plus N2 CV2 upon N1 plus N2 plus N3. So 5N multiplied by 3R by 2 plus N multiplied by 5R by 2 plus 5N multiplied by, what is it? 3R by 2. Oh, sorry, not 3R by 2, 3R only. The whole thing divided by 5N plus N plus 5N. N cancels. Okay. 5 threes are 15 by 2 plus 5 by 2 plus 15. So I will make it 30 by 2. The whole thing divided by 5 plus 5, 10 plus 1, 11. So this will become 15 plus 5, 20, 20 plus 30, 50. So 50 by 2 by 11. This is 25 by 11. Sorry, R was there. R everywhere. R was there. So 25 R by 11. That is CV. Now what you do, find CP of that. Oh, that's it. Enough for me. I think that is more than enough. Now, if I know CV of the mixture, I know one more formula. CV of the mixture will be also degrees of freedom of the mixture into R by 2. That is the formula. CV is degrees of freedom into R by 2. That's the formula, guys. So in fact, if you want all the formulas together, I will put it here. CV is R upon gamma minus 1, which is also degrees of freedom into R by 2. CP is gamma R upon gamma minus 1, which is CV plus R, which is Mayer's law. CP by CV is gamma, which is also 1 plus 2 by degrees of freedom. These are the important formulas which you should know. Coming back, I'm just using degrees of freedom into R by 2 is CV. That's all. So CV of the mixture is 25 by 11 into R, which is freedom of the mixture upon 2 into R. RR cancels. So 25 goes into 2, 11 times is equal to degrees of freedom of the mixture. So degrees of freedom of the mixture is 50 by 11. So 50 by 11 is the D option, I believe. Let's check. Yes, it is the correct option. Okay, got it? So just find CV of the mixture. That's enough. And use N1 CV1 formula. And from that, equate it to FR by 2. So very easily you will get the degrees of the freedom of the mixture. Similarly, you can find CP of the mixture. Similarly, you can also find gamma of the mixture also. Okay, gamma is CP of the mixture by CV of the mixture. Yep, correct. So moving on, some hailstone is falling from some height and converting whole of its energy into heat. How much part of it will melt? Okay, so let's understand what is happening. Imagine there was a hailstone. It falls over here, and when it falls, then what happens? A part of it will melt. Let's say m mass of it will melt. So let's say whole of its kinetic energy, this was 1 kilometer, it had potential energy, here it will have kinetic energy, will be used to melt it. So I can say, since the kinetic energy is used as heat to melt it, this kinetic energy has come from the potential energy of that particular hailstone. Okay, so I can then say, let's assume the original mass to be capital M. The mass which melts is small m. So the potential energy will be capital M G H will be kinetic energy, which will be the heat to melt it, which is small m into L. Now the question is, how much of what part of it will melt? So I am interested in basically small m by capital M. Small m by capital M will be GH divided by L. Now what is this GH divided by L? G value 10. Height 1 kilometer, which is 10 to the power 3 meters. Latent heat 330 into 10 to the power 3. So it will become 1 by 33. So if 33 kgs fall, out of it 1 kg will melt. If 33 grams fall, 1 gram of it will melt. So the answer will be option A. That is what it is. Many students I know, they will not take this m and this m different, and they will end up cancelling this mass and this mass. That is wrong. It is clearly mentioned some of it will melt, or what part of it will melt, means not everything will melt. Did you get it? Why it is different masses? This is a common mistake. Great. Next question on your screen. If there is an ideal gas, volume expansion coefficient is equal to. Volume expansion coefficient is equal to. Okay, let's think. What is the formula for volume coefficient of expansion? A small change in volume, let's say dV, will be equal to original volume into gamma into the change in temperature. This is what it is. So if I want gamma, what do I need? I need dV by V into dt. Oh, so I need somehow this relationship to find the gamma for this particular process or relationship. Okay, let's think. I want dV by V by dt. How do I get it? Maybe I need to look back at this relationship and I somehow need to get rid of pressure. Pressure is, okay, it is nothing but N R T by volume into T raised to 11. That is equal to constant. Okay, NRR constant. So T raised to 1 into 11, we will make it T raised to 12, is equal to some new constant into volume. Is that right? That's what it is. So if I take derivative on both sides, dt raised to 12 by dt is nothing but constant is there as it is, dv by dt over here. What do we exactly get? Let's see. This will be nothing but 12 into t raised to 11 is equal to c into dv by dt. But can I get rid of this constant? Why not? 12 into t raised to 11. This constant is t raised to 12 divided by volume. This is dv by dt. Please note this step. When I came to this step, I've just used the constant from here. Yes, I've just used this constant from here, which is t raised to 12 by v. And from this step to this step, it was just derivative. It was just derivative. Okay, so let's see what exactly happens. So therefore, dv by v dt will come out to be, this will go over here. It will be 12 divided by t, because t raised to 11, t raised to 11 will cancel. So that's exactly what we wanted. So that will be nothing but 12 by t. So 12 by t is option C. It's a beautifully framed question, very different kind, where thermodynamics is coupled with your linear expansions, cubical expansions, aerial expansions. Beautiful it is. Yep, it is not B, Shruti. I hope you saw that. Yep, it is C option. All right. Let's go to some electrostatics questions, and these were the major concepts which came in the January attempt, from the force to the field to the dipole to the flux to the energy stored in the capacitors and capacitors in series and parallel. These were the main concepts that have come in the January attempt, which will tell you this is what probably you can focus on. Maybe it might get repeated. There is no guarantee, Badru. Okay, so let's solve this particular question. The figure below shows hexagon charges are placed in the vertices. Which of the following cases the net field is zero? Now please remember, electric field is a vector quantity, so you have to consider the vector addition. So there might be some symmetry involved somewhere. If there is some symmetry involved, obviously use that symmetry again. So come on, my dear students, can you see some symmetry? Is there some cancellation of forces, etc.? Just think about it. Oh, I can easily say it is the third one, at least for sure. This 2q, the case electric field, 2q will give here, this 2q will give here, this q will give here, this q will give here, this 2q will give here, this 2q will give here. They'll all cancel out. So the net electric field will be zero. Here I don't think they will cancel. because this 2q and q will create an unbalance. The problem is always there somewhere or the other. See, they will create an unbalance. They are not perfectly cancelling out each other. Here also, in fact, this negative will pull, q will push. It is here. These q will cancel. This negative q and q will be in the same direction. So definitely there is a net field. Here also it is not going to cancel, guys. I mean, like, you can see it easily, 5q and 2q. So the net push will be here. 6q and 3q, the net push will be here. 4q and q. So 4q is like going to push it over here more. So this will again create a net electric field. So everywhere else it is not cancelling. Only in this place it is cancelling. So B option is correct, I feel. The third graph. Yeah, the B option, which is the third picture, the third diagram. Yep, correct. Very good. Next, there is an electron. Just read the question. Let me drink some water. There is some electron. It is projected and the kinetic energy is K at an angle 45 between two plates. The magnitude of the field so that the electron just fails to strike the upper plate. Okay, let's see. This is the upper plate. This is the lower plate. And you are throwing this particle like this at 45 degrees. So it goes like that, like that, like that. And just it misses it. There is a separation between the two plates, which we can write it as D. Looks like maximum height, projectile motion and all of that. So if this had a speed u, I think this will have a speed of u cos 45, which is u by root 2. And the reason for that is also simple. See, there will be electric field. So that electric field will give a force, and that force will be Q into E. And that will be constant everywhere because there is a electric field between the two plates. There is a electric field between the two plates. So the question is itself, what is the value of that electric field? Okay, so that electric field is performing the role of gravitational force then. All right, what can we do? Yeah, we can say that work done is change in kinetic energy and all of that. That will give me the answer very easily. So I can just say the total work done by electric force is final energy minus initial energy. That will be easy. Since electric force is like this, displacement is upwards. Yeah, whether it is displacing left and right won't matter because force is perpendicular to the displacement. This displacement matters. So the force, which is electric field into the charge, multiplied by the displacement, which is d, but it is again so negative. Final energy will be half m speed, which is u by root 2 square minus half mass into initial speed. That's it. So the magnitude of the electric field so that the electron just fails over here. Okay, so what can we do over here? Well, this will become nothing but half m u square, the whole thing by half, minus half m u square. But as per the given information, this kinetic energy is half m u square. So if I write this as k, this is also k. So that's it. This is multiplied by half minus is equal to. This will be nothing but minus QE into D. Okay. So let's see what do we go ahead with. Minus QE into D is equal to K by 2 minus K is minus K by 2. Minus minus cancels. So K is equal to QE into D. Therefore, E is equal to K by E into D. K by E into, sorry, not E into D. What is it? E is equal to K by Q into D. Yes. K by Q into D. Is that absolutely clear, guys? Is that absolutely clear? So here, as you can see, this electric field is downwards. So it will not affect the horizontal velocity. So if it was u like this, u cos 45 will remain constant. If it has to just miss, it will just graze through it like it would go through the highest point. This will be u by root 2, of course. And I can say that will be the final kinetic energy, half mu by root 2 square. Initial will be half mu square. And it is clearly mentioned, it is given some kinetic energy, half mu square, which is k. So if this is k, this will be k by 2. The work done by electric field will be force into the distance. Force is charge into E. Displacement is just D over here. That's it. So this will be just k by 2. And I think I missed that 2 over there. 2 will go on the, what did we want? E, right? Wait a minute. K will, yeah. So this will be 2 times of this. So this will become, this will become 2 times. Yeah. So this will become 2 times. K by 2 QD. Correct. Sorry, guys. I by mistakenly missed that 2 part out there. I just realized while checking it. So that 2 will be there below, which is option C, I believe. Let's check it. Yes, it is option C. Perfect. That is correct. Cool. Understood how work per energy used with electric concepts. Let's move ahead with the next question. A horizontal field and mass m, light rod, mass is released, find the angular speed when it reaches this bottommost point. Now this electric field is this way, so obviously it will give a force in this direction, and the force of electric field is the charge into the field. Field is mg by q. Mg by q, that means it is mg. So it is comparable, you cannot ignore gravity now, comparable to gravity, which will definitely act below. Gravitational force will act below. This is mg, and even the horizontal force is going to be mg only. Both are mg. Each force will do work in different directions. That is another interesting thing. So if you see, this electric force is going to displace like this. This particular displacement in the x direction will be this length sine 45 is the length given. I think L, I believe. Okay, so it will be L sine 45, which is L by root 2. Same way, this mg will displace it like this. When it comes from here to here, it is going like this and like this. So equivalent path. So how much displacement is there in the direction of force? That will be this much. And this will be displacement in the y direction, will be the total length minus this much length, which is L cos 45. Yeah, which is L cos 45. So therefore it will be L 1 minus 1 by root 2. That is what the displacement will be in the y direction. Now when you release it from here, by the time it reaches here, there will be gravity and the electric force both doing work, which will in effect increase the kinetic energy. So I will say the total work done will be the change of kinetic energy, which will be half m v square minus 0. Half m v square, the velocity finally will be v. Here it was at rest. So initial energy is 0. Work done by electric force. Force into displacement. So that force is mg. Displacement is L by root 2. Okay. Next, work done by gravity. Force, which is again mg, and displacement is L into 1 minus 1 by root 2. Observe mgl by root 2, mgl by root 2 will get cancelled, and I am just left with now mgl. That's it. This is equal to half m v square. Mm cancels, so gl will be equal to v square by 2. Move it, so 2gl is equal to v square, so v will be root of 2gl. V will be equal to root of 2gl. Is that okay, everyone? Perfect. I think the answers over here have L below, which is I think wrong. Okay, if mass is released, angular. Oh, they have asked angular velocity. My bad, not the velocity. Okay, so if angular velocity is asked, then it will be nothing but omega is v by r. So it will be 1 by L into root of 2gl. So this will be nothing but a root of 2g divided by L. So that is your angular velocity. So that is now your angular velocity, guys, which is root of 2g by L, which is B option. Got it? Perfecto. Shall we go ahead? So many amazing, amazing, amazing concepts, guys. So many of them. Isn't it? Crazy. Let's go. All right. So here comes the next question. Two non-conducting thin shells, charges Q, distance and radius d, sorry, is separated by a total distance of 10d from the center to center. Positive charge is placed inside one of the shells. Then what is the net force acting on the charge? Beautiful question. Okay, let me draw the diagram properly for you guys. This is how it is. Charges are located on the shells. They are all non-conducting. So conductor, if it was there, then the charge distribution would have been affected. Here it will not happen. So this charge is inside the shell, and we know that inside a shell, inside a shell, the net electric field due to the charges on the surface is zero. Therefore, the force on Q will be zero. So this has no contribution only. Forget it. Ignore. So completely ignore this. Completely ignore this. Forget it. Okay, sir. Fine. Then what do we consider then? See, the center to center distance has been given. Center to center distance has been given as 10d. I think this charge is located I think this charge is located at a distance of d by 2, correct? Yes, sir, d by 2. So the question is now, how much force is there on this charge due to this entire shell? Now assume that all the charge is concentrated here, you are outside. So for outside, then what do? Entire charge is concentrated at the center. Think of it as if the entire charge is concentrated at the center. So now the total distance between the two, will be 10d minus d by 2. 10d minus d by 2, which will be 20 minus d, which is 19d by 2. Therefore, the force will be only because of this guy, which will be 1 by 4 pi epsilon naught, charge 1, which is your small q, another charge, which is your capital Q, by 19d by 2, the whole square. So this will be 1 by 4 pi epsilon naught q divided by 19 square is 361 d square, and that 4 will go, 4 will cancel. So q divided by 361 pi epsilon naught d square. That should be the answer. Is it there somewhere? Yes, q by 361 pi epsilon naught d square. Towards the left, obviously, because the charges are positive. So it will be repelling each other. So that's why the force will be towards the left side on this guy. If it was on this guy, it will be towards the right side, of course. Yep, perfect. That's the distance, that's the force. Perfect. So beautiful concept of checking whether you understand field inside is zero versus field outside behaves like a point charge. And they had given two spheres for which one sphere becomes ignored because for that sphere that charge is inside. For the other guy, you have to consider it because this charge is outside that sphere. Okay. Nice question, guys. Let's go to the next one. A wheel having charges masses as shown on diametrically opposite points remains in equilibrium on a rough inclined plane in the presence of uniform vertical electric field, the value of the electric field. Okay, so what can we do? See, over here, this particular charges will behave like a dipole, and that dipole is placed in an external electric field like this. This is an external electric field. That dipole is charged into the length, which is the diameter, which is 2r, and because of which it will experience a torque. The dipole will try to move in the direction of the field, so there will be a torque which will be there like this. And what is the angle between both of them? Well, what is the angle between both of them, guys? That angle will be again theta. That angle will be theta, because if this ground was flat, this angle would be 0. How much ever you rotate it, that much the dipole moment would have rotated. So it is basically theta, the angle between P and E, because this inclination is theta. Okay. Then also I can see that if I take this point, there is normal friction, etc. But mg force is like this. Mg will have two components, one like this, one like that. This will be mg cos theta. This is mg sin theta. There will be also normal. There will be also friction. Friction and normal do not give torque. So torque by friction is 0. Torque by normal is also 0. The torque by mg is like this, which is r into f. R is r, f is mg sine theta. Whereas the torque by the dipole, torque on the dipole due to its electric component will be Pe sine theta. Pe sine theta, whatever is the angle between them. P is 2qr, E is E, sine theta is sine theta. But we know it is given in the question, it remains in equilibrium. So that means these both must be the same to balance it. So therefore, R mg sine theta will be 2qr E sine theta. The question is, what is the value of the field? But before that, RR gets cancelled. That's it. Okay. Wonderful. Sine and, oh, sorry. Everything is sine. Oh, sine also gets cancelled. So this will be nothing but 2q and E. Therefore, E will be nothing but mg divided by 2q. mg divided by 2q, which is B option. Perfect. That is correct. Nice. Loved it, guys. Amazing question. Amazing questions. Very good. Very good. Very good. Awesome. 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 Let's go to the next question coming up on your screen. Let's go to the next question coming up on your screen. An infinite number of identical capacitors, each of capacitance 1 microfarad, are connected as shown in the adjoining figure. Then the equivalent capacitance between A and B is how much? Equivalent capacitance between A and B is how much? Okay, so I can see many branches. This parallel. In each branch, these capacitors are in series. So if you ask me how much capacitor is there in this branch, only one. There are two capacitors in this branch. So capacitance will be C by 2. There are 4 in this, so it will be C by 4. I think there are 8 over here, so C by 8. So like that, they are in parallel. So the net capacitance in parallel just adds. So C plus C by 2 plus C by 4 plus C by 8. It is a geometric progression. So first term upon 1 minus the common ratio, which is 1 by 2. So this will be C by 1 minus 1 by 2 is 1 by 2, which is 2 times of C. But each capacitance was of 1 microfarad. So 1 microfarad. So this will be 2 microfarad. So 2 microfarad is B option. Is that right, everyone? Perfecto. Very good. Let's go to the next one. There are many capacitors in parallel and the combination is charged to some voltage. Now, if they are separated and joined in series, then their energy will be how much? Energy will be how much? N capacitors joined in parallel. like this, C, and they are connected in parallel to some battery. The effective capacitance is C plus C plus C n times, which will become NC. So the initial energy which will be stored, sorry, will be half NC, the total capacitance, into V square. Half NC V square. Okay, perfect. Now what we are doing, we are removing it and connecting it in series. All these are in series to that same battery, C n times. So effective capacitance, first of all, will be C by N. So the final energy stored will be half new capacitance into voltage square. Out of that, you can see half CV square is there as it is. And I want N over here. And here, what I can see, this is N times of half CV square. So now notice if I divide both of them, or not even dividing, forget that. If I just find out from here how much is half CV square, half CV square will be initial energy divided by N. Initial energy, bring N below. Half CV square is initial energy divided by N as it is. And this is 1 by N. So this will be initial energy divided by N square times. So the final energy has now become 1 by N square times the older energy. 1 by N square times. So it decreases by square of the number of capacitors. Square of the number of capacitors. Is that right, everyone? Right. Let's go to the next one. The distance between the two plates, parallel plate capacitor, is 5D. D. Some things are there. Conductor is there here, and dielectric is there here. How will the voltage change in that gap from 1 to 2 to 3? Yeah. Let's see. How will the voltage change in that gap? One thing is there. Wherever you find conductor, the electric field should be 0. So voltage drop should be 0. Because inside a conductor there is no field, so no voltage drop. So from D to 2D, the graph should be flat. From D to 2D, the graph is not flat. The graph is flat. D to 2D flat. D to 2D it's 0, so this is also out of the question. But this is positive, this is negative. So what will happen is the electric field will go like this, obviously. Then it will also go from here to here. Again, inside the dielectric, the field will be slightly less, but it will be there. And again, that field will come back. Again, that field will come back, of course. So always the field goes from high voltage to the low voltage. So the field is continuously going towards the lower voltage. So it should always decrease. How did it increase? How did it increase? It is not possible. It has to be a decreasing or constantly increasing graph only. In this case, it should be decreasing. So this is the most appropriate option, which is B. Is that okay? Clear? Yep. How many of you got it? Option B. Very nice. Very cool. Excellent, guys. Proud of all of you. Moving on to the next section of magnetic effects. Biot-Savart's law, wires, magnetic moving coil galvanometer, parallel forces between wires, magnetic flux, and bar magnets, solenoids, and motion of the particles in electromagnetic fields. These were the most commonly asked topics in your January attempt. So again, you should expect somewhere something like that in the April attempt. Okay, next, proton, deuteron, and alpha particle having same energy are moving in circular trajectories. RP, RD, R alpha are their radii. Then what is the correct answer? In these type of questions where you have a transverse magnetic field, the radius is given by mv divided by qb. So it is momentum divided by charge into field. If you want, you can also write it as 2 times m times kinetic energy divided by charge into field. If you want, you can also write it as 2 times mass times charge into voltage difference by which it was accelerated divided by charge into field. Q gets cancelled, and you can also write it as 2 times m times delta V times Q below and 1 by B outside. This is also okay. All these are equivalent formulas depending on whether speed was same, momentum was same, kinetic energy was same, voltage difference was same. So depending from problem to problem, what is same or not, these formulas will be applicable. Keep these things in mind. So coming back over here, as you can see, same kinetic energy. So the moment same kinetic energy means, look at that, this formula will be most applicable over here. So going back, radius will be root of 2mk divided by qb. Mass is different, charge is different. So R is proportional to root m and inversely proportional to q. Okay, that's it. So if you look at the first radius, radius of alpha, that will be proportional to root of, what is it, proton, right? Mass, charge will be E. Radius of deuteron, that will have a mass of 2m, charge is still E. Radius of alpha is proportional to 4m, charge is 2e, which is the same as 2 cancels, root of m by E. So clearly, sorry guys, this was proton, not alpha. So proton and alpha are equal. Proton and alpha are equal. Deuteron has slightly more radius. Deuteron has slightly more radius. B is not correct. C definitely not. D no. Yeah, A is the only option. A guys. A should be the answer. Perfect. Alpha and proton. Alpha and proton both have the same proportional value. Deuteron is root 2 times of that. So it is slightly more. So that's why A. Cool guys. Can we go ahead to the next question on your screen? Very good. Let's move. Equal current is flowing in 3 infinitely long positive wires. The magnitude of the field at a point 0, 0 minus A. Oh my God. Okay. So 3 wires going in all 3 different directions. Is it? X, Y, Z. Positive. X, Y, and you have Z direction. Okay. And 0, 0, comma minus A, meaning on the negative side of the Z axis. So you are situated somewhere over here. This distance is basically A. This distance is A. Okay. Minus A. Now the question is, what's the magnitude of the magnetic field? So first of all, this wire will not contribute because you are on that wire. So on that wire, no magnetic field will exist because of that wire. So what about this particular wire on the x-axis? Obviously, the current is going like that. So hold it. You will see the magnetic field coming upwards, and it will probably go like this because of this particular wire. And what will be the value? Mu naught I divided by 2 pi A. This is going in the J cap, so this will be J cap direction. Is that fine? So this will be plus J cap. So plus J cap is only there in A, B, and D option. So C option is 100% eliminated because of this minus sign. Next, because of this wire, the magnetic field will go like this. And it will go in this direction, which is negative I cap. So it will be U naught I by 2 pi A, and this will be I cap, but in the negative side because it's going left side to the x-axis. So I think only A option makes sense. Yes, A option is correct. There cannot be K cap component. There is one in this direction, and because of this wire, it is going like this, so towards the left side. Yeah, it will be perpendicular to that wire. Those field lines will be in concentric circles perpendicular to that wire. Yep. Amazing. Moving on. There is a rod, length L, mass M, moving down a smooth inclined plane with a constant velocity as shown. Magnetic field is upwards. Okay, the field is how much? So that, when that current is flowing, the velocity is constant. This is the force on a current carrying wire concept. Force on a current carrying wire concept, guys. So how are you going to solve this question? Let's think. Okay. First of all, the length of the wire is inside the plane of the board. Okay. So if I had to draw a three-dimensional diagram, it will be something like this. It will be something like this. The inclined plane is like that. Okay. And because of that current, IL cross B, length cross B. Oh, the force is there. Interesting. So because of this magnetic field and because of this current, the force is somewhat in this direction, meaning like this. This is that ILB force. ILB force. It's parallel to the ground plane. It's parallel to the ground plane. At the same time, you have a force down the inclined plane, which is mg sine theta. That is like this. That is mg sine theta. Mg cos is there here, but that is not relevant to me. So what I will do, this I will split it into two components, one here and one here. This is theta, so this will be ILB cos theta. So ILB cos theta is that force which is balancing it. So mg sine theta should be balanced by ILB cos theta because velocity is constant. Yep, it is coming down with constant velocity. So there should be no net force. So the only forces down or up the plane are the component of the magnetic force and mg sine theta. Mg cos is perpendicular, which will be balanced by normal. That's okay. This will be normal. This will be mg cos theta. That's okay. What do I do with it? I'm just interested in the parallel components to the plane. So what were we asked? B. So B will be mg sine theta, whole thing divided by IL cos theta. Oh, sine by cos is tan. So mg tan theta by IL. Mg tan theta by IL. Is that clear? Very good. Excellent. Excellent. Let's go to the next question. Question is find the values of magnetic field at the center of these two coils. This is one of the standard most problem which you should know. So see guys, here if the current is going like this wire will produce a magnetic field in the inside direction. So it will be like this, and this part of the wire, again current is going like this, again it will produce in the inside direction. So the magnetic field due to this part will be mu naught I by 2b, but half of it, this half is because it is a semicircle. For a complete circle, it is this. For semicircle, exactly half contribution will be there. Minus, no, plus, because they will add. So mu naught I divided by 2a again into half, again because it is a semicircle. Similarly, if you do it over here, because of that outer wire, curl your fingers in that direction, you will see the thumb goes inside, so the magnetic field will be here. But due to this guy, the current is like this, so the magnetic field will be towards you. So it's the same thing, but now it will be with a minus sign. That's all. So it will be mu naught I by 2b 1 by 2. This will be minus mu naught I divided by 2a again into 1 by 2. That is the only difference, guys. Is that okay? Yep. The only difference is it will be a minus because they will be opposite in direction. That's why that minus. Here it is plus because they are in the same direction. Correct. Moving to the next question, guys, on your screen. A particle of certain charge per unit mass is thrown from the origin with some velocity. Electric magnetic field exists along y direction. The field and EB are given. Okay, particle will return to the origin once. Okay, let's try to think what might happen exactly. So let's say this is the x-axis, this is the y-axis, and this is the z-axis. UI cap and VJ cap, magnetic field is in the y direction. Okay, let's just consider magnetic field for once. Let's not worry about anything else. If this is the magnetic field, UI cap, origin as the coordinates, and minus V J cap, UI cap, UI cap, and minus V J cap. That means there is UI cap and V J cap. My bad, magnetic field is in this direction. So this magnetic field won't even affect the J cap component. This is very, very important. The magnetic field will not apply force parallel or anti-parallel on V J cap velocity 100% because we know the force is Q V cross B. So whenever you have cross product, their cross product will be zero if they are parallel or they are anti-parallel. So for sure, magnetic field being in the y direction will not affect the y component of the velocity. So it can only change the x component. So because of that x component, what will happen? It will go in a circular path like this, I believe. It will go in a circular path like this in this particular plane. Yeah, this is how it will go. This is how it will go in the x direction. Yep, it will go in the x direction. Is that okay, everyone? Now, at the same time, do not forget that there is a y component of velocity, which is minus v j cap. So because of that, that same circle, because of this velocity, will go like this, like this, like this, like this, like this. It will do a helical motion because of that j component. But do not forget, at the same time, there is electric field also in the y direction. So what will this electric field do? Think like this. It will make it go like that, and that electric force will pull it back, and again that particle will go through the origin. So first time it will go down, it will slowly reduce its pitch, and then again it will come back. Again it will come back like this along that same path and pass through that point. So it's very, very important to see. It will definitely form it will definitely form a helical motion, but it will only go till a certain point before it again returns back via that same path. It again returns back via that same path back to its original state. Only because the electric force is pulling it back. So there is a pull by electric force. It's coming back to the same point. Is this absolutely clear, everyone? Why it is coming back to the same point? Excellent. So let's say it goes around n number of times. It goes n number of revolutions. So the total time to go and come back, the total time to go down and come back will be n times the time of each circular motion. Now this time is obviously 2 pi m divided by qb. 2 pi m divided by qb, which is the standard formula. But this time to go and come back by electric force also we can do. I'll tell you how. Just imagine you throw a charge with some velocity like this, but what happens is it experiences a force in this direction. That force causes an acceleration in this direction, which is force divided by mass, which is charge into the field divided by mass. So it goes, stops before again coming back to the same place. So there is a time to return. There is a time to return, just like projectile motion. So this time is just like your projectile motion. Time is 2 times of speed divided by acceleration. So speed is nothing but v, acceleration is nothing but charge into field divided by mass. That's it. This is nothing but n into 2 pi m divided by qb. Well, lot of things will definitely get cancelled out, like this mass and this mass, this 2 and this 2, this charge and this charge. So if somebody asks you what is the value of n, you will say it is v into b divided by e pi. That's it. Yes, vb by e pi. That should be the integer. Yep, perfect. N is an integer. This is definitely that integer which we are talking about. Is that okay? Beautiful question. So what happened is the magnetic field was only affecting this I cap direction. So it was rotating like this. But because of this minus v j cap, it would have gone down as a helix. But this electric field again pulled it back into the same place. So if it did n revolutions, so how much time it took? N into time for each circle, which is 2 pi m by qb. But the time taken to go down and come up by electric force can be also calculated. If you throw it down with some speed, the acceleration will be this way because of the field, which will be force by mass. And just like projectile motion, the time taken to go up and come down is 2u by g. Here g is qe by m, speed is v. That's all. Substitute it, you will get the answer. Loving the question? Yes, no? Come on, put it up in the chat box. Is this question blowing up your mind? If it is not blowing up your mind, then I think you are not appreciating the question good enough, or you are just solving physics for the sake of it. If you love this question, 100% you are appreciating the question and you are doing it for the love of physics. Charged particle enters a field. The path of the particle is seen to follow the path as shown. Which statements 1 to 3 are correct? Magnetic field strength might have increased, definitely, because R is mv by qb. If radius changes, definitely magnetic field would have increased, because of which radius would have decreased. Perfect. Particle lost energy by ionizing. Yeah, that is also possible. If speed reduced because it lost energy, radius will reduce. So this is also correct. Particle lost charge. No. If it loses charge, then if charge is lost, then radius should increase. So this can't be correct. It has decreased the radius. So 1 and 2, which is B option. 1 and 2, which is B option, that is the correct option. Rakesh, I would have thought in the exam we should take the magnitude of the velocity given. Okay, no issues. Cool. So let's go to the next question, guys, coming up on your screen. What do we have? Electron gun is placed, solenoid shoots electron with some speed. The electron never hits the surface of the solenoid. This question. Let's look at the cross section of that solenoid. This is that solenoid. This is carrying that particular current like this. We all know because of that solenoid, the magnetic field will be there inside of it like this. So these dots represent that uniform. B is mu naught Ni, which is the uniform field inside uniform field inside the solenoid. Okay. Now, where is it? Electron gun is placed inside the solenoid along its axis. So if the electron never ever touches the surface, this is the axis of the solenoid. By mistake, imagine some charged particle goes like this. If it should not hit the surface, obviously it will go like this, like this, like this, and it should come back, meaning something like this. That's it. It cannot, it just misses it by some amount. It should just miss it by some amount. That's all. Yeah. So it goes like this. It just barely touches it and comes over here. So that means the radius of the path should be exactly radius of the path should be exactly the radius of the solenoid. Is the radius of the solenoid given? Yes, it is given to be capital R. So capital R, sorry, radius of the path into 2 should be the radius of the solenoid. So this is R, this is R. So 2 times of R. That is what I get. This capital R of the solenoid will be this small r of that uniform circular motion of that particular charged particle. So capital R will be 2 into mv by qb. But wait a minute, what is the value of b? I just told you over here, it is nothing but mu naught ni. Perfect. So I want to find what exactly? Speed, right? This is r. So speed will be, what is there? Mu naught ni q r, whole thing divided by 2m. 2m. Yep, this is the answer, which is, yep, exactly this. Mu naught NIR. This charge will be the electron charge, which will be E upon 2m. Option C. C for Captain Shreyas. So this is a worst case. I mean, anything lesser than this speed will make it go in a smaller circle. The biggest circle will just touch it so that the diameter of the path will be the radius of this solenoid. Yep. Awesome. Perfecto. Cylindrical magnet has some length and diameter. It has the magnetization of this much. What is the magnetic dipole moment? What is the magnetic dipole moment? Come on, guys. This question is based on intensity of magnetization, or magnetization is the total magnetic moment divided by the volume. So our magnetic moment in total will be intensity into volume. Volume is area into the length. So area is nothing but pi r square. So into length. So I value is given, which is 5.3 into 10 to the power 3. Pi is 3.14 and r radius is 5 centimeters or something. Diameter is 1 centimeter. So radius is 5 millimeters, which is 5 into 10 to the power minus 3. So 5 into 10 to the power minus 3 whole square into the length. Length is 5 centimeters. So 5 into 10 to the power minus 2. Solve this. I think you will get the answer as 2.08 into 10 to the power minus 2. So this will give you 2.08 into 10 to the power minus 2. The formula used is intensity is magnetization divided by the volume. Volume is area into length. Area is pi r square. That's all. Next, two magnets perpendicular. Question is magnetic field at the distance d from the center. At a distance d from the center. There are multiple ways of doing it. One lame method will be due to this find the field here, due to this find the field here, and then do vector addition, which is complex. Instead, why not take the net magnetic dipole moment? Yes, this is one magnet like this, there is one magnet like this. Both of them have a magnetic moment of m. So obviously their net magnetic moment will be m root 2. This will be net. For that net magnetic moment, this particular point is on the axis. So the magnetic field at point P will be mu naught by 4 pi, okay, 2 times of the net moment divided by the distance q. And this net magnetic moment, I just told you, it is m root 2. Oh, perfect. So what is the correct answer, guys? There is only one option. Yeah, C for Captain Shreyas. Yep, that is the correct answer. This is the easier way because magnetic moments are vector quantities. Find the net moment. So when you see that the point P is on the axis, so 2 times will come. If it was on the equator, then that number 2 will not come. Yeah. On the equator, it is half as compared to the field on the axis. That's the logic for it. Okay. So the next one, the magnetic moment of molecules of paramagnetic gas is this much, the temperature is this much, the number of molecules is this much, maximum possible intensity of magnetization. Again, the same formula if I'm not wrong. Magnetic moment per unit volume is nothing but uh, intensity of magnetization. So therefore, I will be the maximum possible intensity of magnetization. Uh, the dipole moment of each molecule is 1.5 into 10 to the power minus 23. How many molecules are there? Uh, yeah, that is basically 2 into 10 to the power minus 26, sorry, plus 26 molecules per meter cube. So divided by 1. So that's it. This is what it will be. 1.5 into 2 is basically 3. So this will be 3 into 10 to the power 3. 3 into 10 to the power 3, which is option A, of course. How did I get this? Because remember, the total magnetic moment will be the number of molecules multiplied by magnetization of each molecule. That's what. Magnetization of each molecule and number of molecules. If you multiply, you will get the total magnetization. Volume was already given. This was per unit volume. So that means volume will be 1 meter cube. Perfect. So it's time for a break. We'll just take a small break and then we'll return. Okay. We'll not take much. We'll just take it for 15 minutes or so, the break, and then we'll return and we'll try to wind up this session by 5:30 or 5:15 or something like that. Just give me a 15 minutes break. Okay. We'll return. Okay, so I hope you guys are ready for the last leg of this particular 100 questions concepts from physics. Tomorrow, maths, then chemistry, of course, following up. So the break time is over. I hope I'm audible and visible. Quickly let me know in the chat box. So let's begin with the next part. Just one second. Yeah, that's ray optics. So a lot of questions from total internal reflection, your prisms, refractive indices, as well as the lenses and the mirrors formula, especially even the powers, combination of lenses, which were asked in the January attempt. One of the highest weightage topics was ray optics. Cool. So let's begin. Hi Rakesh. Hi Pratik. Welcome, 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 welcome. Yep, I hope I'm audible and visible to all of you. Yeah, this is the last break and then we are starting. Hi Joseph, hi Alapichai. Welcome aboard. So there is a diverging lens of certain focal length 10 centimeters in front of the plane mirror. Light from a far source falls on the lens. The final image is at what particular distance? Okay, that's the question. So let's understand what exactly might happen. See, from a very far away source means the rays are almost like parallel. The rays are going to be almost like parallel. So after they are parallel, because it's a diverging lens, it will go like this, and the image will be formed somewhere over here. The image will be formed somewhere over here. Is that right? Correct? Okay. Now, what will happen next? This particular distance, we can easily find out where that image will be formed. This is the first image. The focal length of the lens is 10 centimeter. So therefore, it will be formed at a distance of 10 centimeters behind the lens, and this will be obviously a virtual image. This will be obviously a virtual image. But that's not the end story. What you need to do now, observe carefully. The ray will not stop there, obviously. So it will reflect from there also. It will reflect from there also, like this. So the moment it reflects from that particular mirror, it feels the image is now behind that particular mirror. And I know I don't have space now. Just imagine you are now at a distance of 10 and 10, which is 20 centimeters. This is your image I2. What is that? That is basically your image I2 behind the particular mirror. Okay. Now just imagine there will be many such rays. Now again coming back, see this particular concave lens which is there. That image which is there, I2, that image which is there, I2, that technically is 10 plus 20, which is 30 centimeters behind that lens. It is technically 30 centimeters behind the lens, which will now act like the object for the third event, which is the refraction through the lens. The parallel rays diverged as if they are coming from this point. 10 centimeters was the focal length. They will go hit the mirror, get reflected. So whatever this image is there will feel as if it is coming from behind. This was 10, this was 10. So totally 20 centimeters behind. So 20 centimeters from the mirror is 30 centimeters from the lens. Now, these rays, when they come from that particular object, these rays when they come from that particular object, obviously they will again diverge further like that maybe, and they might form some image somewhere else. So now let's apply our lens formula and solve the problem. So 1 by v minus 1 by u is equal to 1 by f. Needless to say, since this is the direction in which the incident rays are going, so obviously this side will be the positive side, this side will be the negative side. So image I do not know. Object distance is at a negative 30 centimeters. Focal length of a concave lens is negative, so minus 10. So therefore this will become 1 by v plus 1 by 30 is minus 1 by 10. Solving further, 1 by v is equal to minus 1 by 30 minus 1 by 10. LCM is 30. So it will become minus 3 minus 1 minus 3, which is minus 4 by 30, which is minus 2 by 15, that is 1 by v. So therefore v will be minus 15 by 2, which is minus 7.5 centimeters. So 7.5 centimeters behind that lens. So that image will be as if over here, this is the final image, and this is obviously 7.5 centimeters. Hence, check out from the mirror they have asked. From the mirror, it will be, if this is 7.5, if this is 7.5, from the mirror, it will be 2.5, because this distance is 10 centimeters. This is nothing but 10 centimeters. Is that right? So hence D option will be the correct answer. Check this out if this is okay. So there were multiple reflections and refractions happening, and whenever such problems come, which is very likely in your JEE mains exam, the image of a first reflection or refraction becomes the object for the next. Like over here, this image became the object for the mirror. So if you are standing in front of the mirror, the image comes behind. That image then became the object, because the rays will again come back through the lens. So that becomes the object for the lens again. So that's how you proceed, and sign convention has to be taken care of. Moving on to the next question. The angle of incidence versus deviation graph is shown, and for a prism, the refractive index of the prism is. We know that minimum deviation occurs when angle of incidence is angle of emergence, and that is happening over here. So this is your minimum deviation, and this is your angle of incidence, which is also the emergent angle. So we know there is a formula. Mu is sine of angle of prism plus delta minimum by 2 divided by sine of a by 2. Is it mentioned what type of prism it is? No. Has been angle of prism versus angle of deviation has been plotted over here. I is equal to E, that's all they have told. So we can use one for formula. Delta M is equal to I plus E minus A. Delta M is 60. I and E are both again 60 and 60. So minus A, 60, 60 cancel. So A will just become 60 degree. So substitute it here. So sine of 60 plus 60 by 2 by sine of 60 by 2. This is sine 60. This is sine 30. Sine 60 is root 3 by 2. Sine 30 is half. So it will just become root 3. So root 3 is option A. Yep, that is the correct answer. Here I did not know whether it was equilateral. So I had to figure it out using this formula. This formula is again very crucial in your prisms. All those prism formulas, please remember it. Yep. There is one more prism formula. If you remember, R1, internal angles R1 and R2 together give you angle of prism. It was not needed, but just telling you about it in case it is needed in some other question. Parallel beam of white light falls on a convex lens. Okay. Parallel beam of light falls on a convex lens like this. And there are multiple colors and we know blue, red and green. Okay. So red and blue. Okay. So first of all, out of red, blue and green, who deviates the most, who deviates the least? So if red color goes like this, let's say it's going here. If you talk about the blue color, come on guys. Violet, indigo, blue, green, yellow, orange, red, it starts from below. Yes, the violet is the one which deviates the most and the green color is in between somewhere like the yellow. So it will be like this. This is how the colors will deviate and where the image is formed on the other side. So as you can see, if this is our principal axis, who is the closest? The blue one, then green, then red. Red is the farthest. Red is Z, so Z is the farthest. Z is the farthest. Parallel beam of light forms on a convex lens. Images blue, red, and red is sorry, not Z, it is Y. My bad. Y is the farthest. Y has to be the maximum, so it should be C option. Yep, it is C option. Check this out. So the red one was Z. Sorry, red one was Y, as you can see. So this Y is the maximum, whereas the blue one is X. So that one was minimum. Okay, I hope this is absolutely clear, guys. So you should know that violet deviates the most. VIBGYOR V is highest refractive index. Yeah, VIBGYOR, violet, indigo, blue, green, yellow, orange, red. Red is the least deviating, least refractive index among all the colors. Yeah, perfect. Cool. Shall we go ahead to the next question on your screen? Here it comes. Get ready, guys. Yep, I want everybody to be fully focused on the session, guys. Yep, everybody. Next one. There is a convex lens of certain focal length and diameter cut along the line AB. The part of the lens shown shaded the diagram is now used for blah 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 30 centimeters away from the line XY, which is perpendicular to the plane of the lens. Okay, fine. Now here is the catch. Let me show you what that catch is. See guys, this was your lens and it was very clear that the diameter is 5 centimeters. That means the radius is basically 2.5 centimeters is the radius of that aperture. But what you have done, you have only considered this much part of the lens. So imagine somebody just gave you this much part of that lens and that much part is essentially nothing but 2 centimeters. That is what it is. It is just 2 centimeters of that lens. That means the original principal axis, which would have been this. This is our original principal axis. Is over here. Only this much part of the lens is being considered. The remaining part of the lens is not given to you. You have been given that an object is placed at 30 centimeters. Object is placed at 30 centimeters, maybe over here. This is our object. Fine, this distance is 30 centimeters. Fair enough. That is 30 centimeters. So this is the negative side. This is our positive side. The question is, where will the image be formed? Okay, of that particular point. Okay, so if this is our object, where will the image be formed? Let's think about it. And do not forget, this orange dotted line is where you are cutting that lens. That is your line XY. That is your line XY, which is right over here. Many students fail to realize that the line XY is not the principal axis of this cut part of the lens, because the principal axis is that axis which cuts the lens equally into equal halves. So this is not that equal cutting line, so it can't be the principal axis. So please remember, the principal axis is somewhere over here. This is our original principal axis. So that distance between the two, XY line and the principal axis is 0.5 centimeters. So actually what has happened is, you have placed the object not on the original principal axis, but rather on that line XY, which is over here. Yeah. So this is your XY line, and that object has been technically placed over here. So consider that as the object, where this is now 30 centimeters over here. So this object will form an image somewhere here, which I do not know where it is. We'll figure it out. From that, we'll be able to solve the problem. And this height of the object is exactly 0.5 centimeters, which is this particular width. This particular width is 0.5, because this is 2.5, this is 2, this is 0.5. So the object height is what 0.5 centimeters is, and that is important in solving this problem. Let's use our lens formula. 1 by V minus 1 by U is 1 by F. So 1 by V minus 1 by minus 30 is equal to 1 by the focal length. How much is the focal length? Check this out, 20 centimeters. So put 20 over here. Therefore, 1 by V plus 1 by 30 is 1 by 20. Therefore, 1 by V is equal to 1 by 20 minus 1 by 30. So therefore, 1 by V is equal to, this is 60, this is 3 times, this is 2 times, which is 1 by 60. Therefore, V will be 60 centimeters. So it is positive, so the image will be formed somewhere here. Okay, but what's the magnification? Magnification is nothing but minus V by U, which is image height, by your object height, which is minus of image distance is 60, object distance is minus 30, which is 2. Image height by object height is 0.5. This was 0.5. So image height is basically 1 centimeter. And since the magnification is positive and it is image height is also positive, that means the image will be 1 centimeter tall. So this is where the image will be, and this will be 1 centimeter. Now, if you compare it with respect to this XY line, because already this was 0.5 centimeters. So how far will that image be from this particular line? Yes, it will be on the top at a distance of 0.5 centimeters. and this will be nothing but 60 centimeters. And this image will be obviously real image. So hence the answer should be, I think they have given it wrong, xy 1.5 below xy. Oh, sorry, guys. I wrote it exactly ulta. I'm so sorry. This was our principal axis. Uh, yeah. So our object is placed here. Okay, let's just check. Have they made a mistake or what? Point P on the XY line. Okay, on that XY line for sure. So it should be 0.5 centimeters above XY axis. Yes. So as you can see over here, 0.5 centimeters above the XY line on the top. So therefore, this should be the correct answer. This particular should be the correct answer. Option A. Yep. Okay. Is this clear, my dear warriors? Understood? Clear? Let me know quickly in the chat box. Perfect. Awesome. How about this question? A convex mirror of focal length f is placed at the origin with its reflecting surface towards the negative x-axis, with its reflecting surface towards the negative x-axis. What do you think should be the correct answer for the UV graph? For the UV graph, come on. With its reflecting surface towards the negative x-axis means, what is this? Convex mirror, right? So it is like this. So this is your negative x-axis. This is your positive x-axis. Okay. So what is the correct graph for image distance and object distance when the object distance is less than 0? So if you place an object over here, where will the image be formed? It will be formed over here. So object, if it is on the negative side, image is on the positive side. Is that right? Object is negative, image is positive. So U is negative and V is positive. So think about it in our this is U versus V graph. V has to be positive, image object distance has to be negative. That means it has to be in this part, the second quadrant. It has to be in the second quadrant. Is that right? It has to be in the second quadrant. So I think all of them are in the second quadrant, but which of the following are is correct actually? Okay, come on, guys. Think about it. One of them is absolutely correct. Everything else is wrong. Okay, take some special cases. Take some special cases so that it will help you. If object distance is infinity, what will happen to the image distance? It will tend to the focal uh, point. F will be positive F. Object distance tends to infinity. No, option A got eliminated. See, when object distance is basically minus infinity, image distance is tending to 0. No, this is also incorrect. This is also incorrect. This is the only correct, because you can see over here, object distance is tending towards negative infinity, image distance is tending towards the focal length. Perfect. This is absolutely correct, guys. This is absolutely correct. So only option C is matching. So yep, that is the correct answer. Just try to eliminate. It will become very simple. Else you will be stuck. Sir, can you make a video for DOSA CIWG students writing JEE from Gulf cutoff for NITs? Oh, definitely, Jitesh. Point noted, but hopefully there are quite a few students who watch these videos from Gulf. Let me know if many Gulf students who do watch the J English channel, because our analytics say a decent chunk, a couple of thousands of students to watch it. So I'm guessing we have a decent audience. But I would like to see that in the comments also, so that we can make some Gulf country specific videos as well. Okay, moving on to the next one. There is a lens placed between the source and the wall. Two images are formed for different positions. Okay, now this kind of questions where you have a wall and let's say a source, let's say a source of light like this, This is your source of light. This is your wall. Then you get two positions. Then you get two positions of the lens separated by a certain distance. Let's say call it as x. And this distance, let's say call it as d, for which you will get two times the real image. You will get real image once here and once for this position on the wall. This is called as lens displacement method. Lens displacement method. Lens displacement method to find the focal length. To find the focal length. Now, in this particular method, what happens is whenever you get the images, the height of image first time, height of image second time, the geometric mean comes out to be the height of the object. That is how it is. So, if I have to compare the areas of the image, the area of the source light. So, just imagine if I square this, HO square will become root of H1 square and H2 square. I'm just squaring both sides. Is that right? I'm squaring both sides. If you see height and height, squaring it will give me the area. This will give me also area. This will also give me area. But this will be the areas of the images. This is the area of the source. This is of the source. This is of the images which are formed. Yeah, both the times the real images that you get are not of the same size, they are of different sizes. So the root of each image size multiplication is the size of the object. This is the formula that you need to keep in mind. Is that okay? So hence, therefore, you will see the answer is root A1, A2. Not just that, this distance x which is there, this distance x which is there, it is always going to be more than, it is always going to be more than 4 times the focal length. Yeah, whatever is the focal length of the lens, it will be more than 4f whenever you do this lens displacement method. Yeah. Moving on, next question. There is an object and a screen fixed distance d apart. F is the focal length and you are getting sharp images, again two positions, lens displacement method. Okay, the magnification produced are, oh guys, I just told you the magnification produced at both these points are M1 and M2. So I mean, just look at it. If height of the object is root of height of the image, square it, HO square will be H1 into H2. So therefore, I can write 1 is equal to H1 by HO and H2 by HO. So what is this? Magnification first time, this is magnification second time. So therefore, M1, M2 is equal to 1, 100%. And even this is also true. I think some options are missing saying B and C are correct because in JEE means you only get single correct, not advanced type. So there could be options like B and C are correct, 1 and 3 are correct, something like that. So this should be more than 4F. Yeah. M1, M2 is 1 and distance is more than 4F. Is that okay, everyone? You just brought HO below so that it looks like magnification, because we know magnification is height of the image upon height of that object. That's what magnification is. Okay, let's go. You will get a very good score, Tirupati. I can't tell you how much marks, but you will definitely get a very good score. That's all I can assure. Okay. The block of glass and refractive index is in contact with the surface. Okay, a beam of light is incident on the vertical face of that block. This is the vertical face. After total internal reflection at the base and the refraction at the opposite vertical face, the ray emerges out at an angle theta. What is the value of theta? If water has N2, this has N1. Okay, let me see. This is N2, this is N1. The ray of light coming like this, going like that, going like this, going like that. Now see guys, if this is theta, well, if it has to get internally reflected, that means this angle will be the critical angle. This will be also IC. If this is IC, this is 90. Obviously, this will be 90 minus the critical angle. Is that right? 90 minus critical angle. Just check this out. Okay, perfect. Now, that is what is exactly given in the question. The light falls on the vertical face, gets internally reflected from the horizontal base, and then again comes out from there. So, what's the relationship of that theta and the refractive indices? Okay, so one thing I can say that the sine of that critical angle is 1 by refractive index of the dense medium with respect to the rare medium. Now, please understand this is water or whatever that liquid is, should be the dense medium, because of which it is getting totally internal reflected in this rare medium. So, this is the exact point where your total internal reflection was happening. The light came here and reflected back here and finally came out from this side. Came out from this side. And same thing will happen here. No doubt. This will be also theta and all symmetry will be there. Okay, so this is nothing but refractive index of dense here, refractive index of rare on the top. Rare medium is N1, dense medium is N2. So this is sine of IC. But that's not what is asked. I have to find theta, and these two are related by Snell's law, of course. Is N1 only? Okay, outside medium is, I think, air only, I believe. Okay, fair enough. So I can say N1 sine theta 1 is N2 sine theta 2 using Snell's law. Using Snell's law. N1 over here is N1 only. So N1 sine theta 1, here it is 90 minus IC, is equal to N2, which is air, into sine theta, which is the outside angle. Okay. So this will become N1 sine 90 minus theta is cos theta. So this will be cos IC is nothing but sine theta. But what is cos of any angle? It will be by our identity root of 1 minus sine square theta. So it will be this. And why do I need that conversion? Because I know sine theta only, I do not know cos theta. So that's why I use the trigonometric identity there. So therefore, n1 root of 1 minus sine square. So sine square means n1 square by your n1 was, sorry guys, I made a big blunder here. Sorry. I tell you what, this was exactly opposite. This was supposed to be exactly opposite. So sorry, I made a small blunder. If it is internally reflected, this should have been rare medium and this should have been the dense medium. Sorry, because internal reflection happens within the denser medium. It should get reflected inside the denser medium. So technically, this should have been denser means over here, which is N2, and this is N1, the rarer medium. Rarer medium. Okay, now it seems to be correct. So now N1 into root of 1 minus sine square IC. So this uh, rarer. Oh, sorry, what am I doing, guys? I wrote here correctly. So sorry. N2 is rarer. So N2 should come on the top. N1 is denser. Denser will come below N1. My bad. Apologies for the confusion. I'll just repeat because it was denser below. So that's why N1 will come over here, which is that denser medium. And this is the rarer medium, which is supposed to come over here on the top. Is that okay? Perfectly fine now. Okay. So I have N1 and then root of 1 minus sine square of IC. Sine square of IC means N2 square by N1 square is equal to, this is just sine of theta. So therefore, N1, this will be N1 square minus N2 square, whole thing by N1 square is equal to sine theta. So therefore, sine theta will be N1 square will go outside and will cancel. So I'll just be left with n1 square minus n2 square. Just check this out. N1 square minus n2 square. Yep. So this should be there somewhere. N1 square minus n2 square is sine theta. Perfect. That is the correct answer. So we needed little bit of geometry over here because or else I cannot relate both of them. And I always needed the concept of total internal reflection, and finally the concept of Snell's law. Is that okay, my dear students? Yep. Great. Awesome. Awesome. Let me know if you guys got this. Shall we move ahead to the next one? Wave optics related questions. In a Young's double slit experiment, 15 fringes are seen in a portion of the screen where the wavelength is 200 nanometers. If 10 fringes are observed on the same section, when you use another light, then what is that new wavelength? See, if you have a portion on which you are seeing certain fringes, let's say there are each fringe width is beta, and like that, from 1, 2, 3, 4, like that, there are n fringes. This particular length will not change, it is constant. So beta into L will be a constant, sorry, beta into number of fringes, beta, 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 n times will be the length. That will be a constant, but the fringe width is lambda d by d into n, which is a constant, but d and d will not change. So lambda into n is a constant. That is the trick which you will use for these kind of questions, where in the same place you are going to, yeah, same place you are going to fit in a different set of fringes. Veda, yeah, it is less than because there was a condition which was asked. We found it for the critical case in the previous question. So when we find for the critical case, we'll obviously get equal to. But when you say that, okay, it has to emerge out, then obviously that more than less than conditions will come, right? So you always try to solve for the critical case, like even in what is the maximum speed for which the car can go around a banked road. So you find V is root mu rg, but that is not the actual speed with which the car can go. The car can go at much lesser speeds also. You always try to solve for the extreme speeds or extreme conditions. Is that okay, Veda? Fine. So lambda 1, what is lambda 1? 200. Number of fringes 15. Second time lambda, number of fringes 10. So obviously lambda will be 20 multiplied by 15. So it will be 300 nanometer. So 300 nanometer is option C. Is that okay? That is the correct answer. Everyone, shall we go ahead? Very good. Excellent. Moving on. Wow. Crazy question. In YDSE, there is a medium who is having refractive index N1. It enters into another medium whose refractive index is N2, but there is a slab which is placed only in the path of one of the rays, because of which there will be a phase difference. The question is, what is that phase difference? Okay. The wavelength of the light in this medium is lambda 1. Okay. So let's understand. The wavelength of that light here is lambda 1 in this medium. Obviously, by the time the light will reach here in this particular medium, see here it was lambda 1, here it is lambda 1, but here it will be some other thing. So what will be that wavelength, guys? I think we know the concept over here. Yep. Speed of light will change, frequency will remain same, so lambda will change, right? That's how it goes. So lambda 1 by lambda 2 will be speed of light in the first medium upon speed of light in the second medium, which is also you're going from first medium to the second medium. So refractive index of the second medium with respect to the first medium, which is obviously n2 by n1. Therefore, lambda 2 will be n1 lambda 1 by n2. Just check this out. n1 lambda 1 divided by n2. That's the wavelength in this medium. That is the wavelength lambda 2 in this particular part where things are going to interfere. That is what I will need, because that is the wavelength which will interfere at the end of the day. This lambda 1 will not interfere. Everybody fine till this point? Okay. Now, this particular slab which is there, this slab introduces a path difference. How much will it be? Do you remember the formula? Yep. Do you remember the formula, guys? What is that path difference? It is definitely going to create a path difference. It is the thickness into the relative refractive index minus 1. Relative refractive index minus 1. Okay. So what is that relative refractive index? It is N3 by N2. Oh, so it is N3 by N2 minus 1. Okay, so that is the path difference. So what is the phase difference? Phase difference is 2 pi by lambda, whatever that 1 is, sorry, lambda 2 that is, into delta x. So it will be 2 pi divided by lambda 2. Lambda 2, I just found it out, n1 lambda 1 and lambda, sorry, n1 lambda 1 by n2. So n2 will go on the top into delta x. What is delta x right over here? Which is thickness into n3 by n2, sorry, n3 by n2 minus 1. N2 n2 cancels, so n3 minus n2 will be here. So 2 pi by, okay, I don't have much space, 2 pi by n1 lambda 1. Then thickness is also there. N2 n2 cancels. N3 minus n2. That is what it should be. So 2 pi thickness n3 minus n2 n1 lambda 1. I think A option is the correct answer. Yes. Now this is a brilliant question because multiple refractive indices are there with a glass slab in between. So this is, I feel, a must do question in case they twist the question and give it to you for different mediums. So you have to first of all convert the wavelength to the wavelength which is actually interfering. And whenever you use this formula, that is thickness into relative refractive index minus 1 formula. Okay, these formulas were again very important. Let's go to the questions on modern physics, guys. Ready for it? Shall we go to the questions on modern physics? Ready? Yes, no. Come on, my dear students. Already almost like 7 hours we are closing in. Yeah. This lecture is almost going to go on for 7 hours. I did not plan it for 7 hours. I thought it will be over in 5-6 hours. But obviously, I'm explaining each and everything in this lecture. I'm trying to make it as simple as possible for all the students, and so that you understand all the solutions in proper way. I'm solving it not as a teacher, I'm solving it as a student. If you do silly mistake, I will also do mistake. If I do some thing problem while solving, that's okay, because exactly how you would think in the examination also. We're trying to keep it as minimalistic, as reasonable, as simple as possible, as practical as possible, guys. A particle is moving in the x-axis back and forth in a box. Assume some de Broglie hypothesis, okay, and it is moving with a constant speed in the box, making perfect elastic collisions to the walls. The possible value of the momentum of the particle is okay. So imagine there is a box and that particle is going back and forth. So what will happen? It will have its de Broglie wavelength and it will form a kind of a standing wave. It will form a standing wave inside that particular box. So if this length of the box is L, so there will be one wavelength. Each lobe will be lambda by 2. Lambda by 2 will be that lobe of that standing wave. Like that, there are n lobes. N lobes. So I can say lambda by 2 into n is equal to the length. And lambda is h by momentum. And half is there, n is there, is equal to L. So momentum, if you see, is hn by 2 times of length. Hn by 2L, which is option A directly. So how did it click that we have to use standing waves concept? See, guys, if that block is, sorry, whatever, that particle is stuck in between and de Broglie hypothesis is applicable. So remember the concept of standing waves. Two waves going in the opposite directions interfering produces a standing wave, which is a trapped form of energy. So in this box, When I'm not seeing it, I do not know whether the mass is existent as a particle or a wave. But here they assume it is existing as a wave, which is the matter wave. So imagine the matter wave of that particle is trapped inside that box. That matter wave is moving back and forth, forming a standing wave. Both sides it will be having a reflection. So it is like a standing wave on a string fixed at both ends. So that interference pattern of that matter wave is giving us the probabilities of finding that particle inside that box. Okay, it's crazy to think about it. How the matter wave producing a standing wave when you are not observing it. It's a crazy concept, but that is what they have asked us to use. Okay, and the reason why elastic collisions is given is because those two waves will hit back and forth and no energy is lost, or else the energy will slowly die out and the wave will get destroyed. Meaning there will be nothing to interfere as such, isn't it? So that's the reason for it. Okay, how about this question? Stopping potential versus frequency of a light falling on a metal is shown. What is the work function of the surface? Stopping voltage, frequency. We all know that this graph's slope is always a constant, which is h by e, and this point is always the threshold frequency. Now, what is the question? Work function is asked. What is the formula for work function? It is hf naught, right? So h is 6.6, 10 to the power minus 34, and frequency 5 into 10 to the power 14, but that is in joules. So do not forget to convert it into electron volt. So 6.6 into 5 into 10 to the power minus 34 and 14, guys, that is minus 20, divided by 1.6 into 10 to the power minus 19. This will be an electron volt. So approximately how much answer are you going to get, guys? Come on. How much answer are you going to get? 1.6, 6.6 into 5. This will be minus 1. So 6 5s are 30. So 3 and 1.6, close to 2. So this will be 2.07 electron volt. I did not sit and solve this. I just thought 6 5s are 30. So 30 is 3 into 0. This will give me 10 raised to minus 1. 10 raised to minus 1 and that 0 will cancel. So I'll get 3 and this is 1.6. 3 by 1.5 is 2. So 3 by 1.6 close enough to 2. And I have not considered that 0.6 initially. So maybe around 2. So that is why I said it is 2 electron volt. Perfect. That is correct answer. Okay. Shall we go ahead? Next question coming up on your screen. Here it is. Photoelectric experiment. Electrons are ejected from metals X and Y by light of intensity I and frequency F. The potential difference required to stop the electrons is measured for different frequencies. Okay. If Y is greater work function than X, Y has greater work function than X. So the threshold frequency of Y will be more than threshold frequency of X. Remember, potential versus, whenever we have a graph of potential versus frequency, wherever it hits, that is your threshold frequency. So for Y, the threshold frequency should be more. Y, the threshold frequency should be more. Can you see that over here? Exactly. So frequency of Y is more than frequency of X. Perfect. So it is higher. Hence, this is the graph. Slopes should be equal. Yeah, slopes are always constant, h by e, which is the same no matter which wavelength, no matter which metal you use. Let's do some questions on atoms and nuclear physics also. Let's do some questions on atoms and nuclear physics also. Yep. Okay. Okay. All right. All right. Perfect. Let's go. Let's go. The electron in hydrogen makes a transition, and N1 and N2 are the principal quantum numbers. Assume Bohr's model. Frequency in the initial state is 1/27th of the final state. Frequency. What is frequency? Frequency is 1 by time period. Time is distance by speed. So circumference by speed. Now we know speed is basically z by n proportional, so some constant into z by n. Circumference is 2 pi r, radius is some constant into n square by z, n square by z. So this will all be some constant, n is there here below, so 1 by n cube. So frequency is inversely proportional to 1 by n cube. Now it is clearly mentioned frequency of the electron in its initial state, that means n1 upon n2 is 1/27. So this is inversely proportional. So n2 by n1 whole cube is 1 by 27. So n2 by n1 is 1 by 3. So therefore, if n2 is 1, n1 is 3. N2 is 1, n1 is 3. I think B option seems to be the right option. None other options are in the ratio of 1:3. So B option for IIT Bombay, I feel. Yes, it is the correct answer. Okay, very good. Awesomeness. Awesomeness, awesomeness, awesomeness. Moving on to the next question. If 917 Armstrong be the lowest wavelength of Lyman series, then the lowest wavelength of Balmer series will be. Lowest wavelength means highest energy. Keep that in mind. So 1 by lambda, and I want the minimum wavelength, is a Rydberg constant z square 1 by n1 square, and this will be always infinity. Yep. Because I want minimum wavelength, so energy difference will be maximum. That means the second energy state will be at infinity level. N is infinity. Okay. So this will as simple as become Rz square by n1 square is 1 by lambda minimum, or lambda minimum is directly proportional to n1 square. Now you just have to do it for Lyman and Balmer. So 917 Armstrong by whatever Armstrong is there second time for Balmer is, for Lyman n is 1, so 1 square. For Balmer n is basically 2. That's it. So lambda will be how much? 917 multiplied by 2 square. So how much will lambda come out to be, guys? Just check it out. Is it 3668? Is it 3668 Armstrong? That is the answer. 7 4s are 28. Yes, 3668. 3668 Armstrong. Perfect. Very laddu question, just based on the Rydberg's formula. Okay. Let's do the next one. The binding energy of X and Y are E1 and E2. If two atoms of X give you the atoms of Y, the Q value is how much? It's a beautiful question. Let's understand. Let's say some number of protons and some number of neutrons give you X. Okay. So this is the mass of the protons and some number of neutrons. So let's say some n1 number of protons and some n2 number of neutrons give you basically X, and there is binding energy E1. Now what happens is it is mentioned to us that 2 times of X gives you Y. 2 times of X gives you Y. This also means that if I had 2 n1 times of protons and 2 n2 times of neutrons, I would have got the element Y with some binding energy E2. Happens 2x combines to give you Y. There is an energy release which is called as the Q value. This particular Q value, my dear warriors, is always the energy which is there, of the product, binding energy of the product minus the binding energy of the reactants. So it is always the binding energy of the product which is there minus the binding energy of that reactant. Now, if you see, the binding energy of the product is nothing but E2, binding energy of the reactant, which is E1, but there are two of it, so 2 times of E1. That's it. So E2 minus 2 E1, that should be the correct answer. E2 minus 2 E1, that should be the correct answer. Option B. Perfect. Is that okay, everyone? Yep. Clear? Yeah. We don't have to do any kind of balancing. Just remember this formula. Yeah. Binding energy of the product minus binding energy of the reactant directly gives you the, yeah, Q value of that reaction. Okay. Next, the electron in a hydrogen atom's first jumps from third excited state to second, and then from that it goes to first excited state. So third to second, second to first excited state, the respective wavelengths are what exactly? Okay, so this is your ground state where n is equal to 1, then n is equal to 2, then n is equal to 3, then n is equal to 4. This is first excited, this is second excited, this is third excited state. So lambda 1 is from third excited to the second excited, third to the second excited, then to the first excited state. So that means from here to here. So this is lambda 2. So question is, what is the ratio of the wavelengths? Use Rydberg formula. So what is lambda 1? 1 by lambda 1 will be Rydberg's constant. N I should use, not excited state number. So this will be 1 by 3 square minus 1 by 4 square. 1 by lambda 2 will be Rydberg constant. 1 by these numbers I should use, 2 square and 3 square. Now I will obviously divide them to get the ratio. So 1 by lambda 1 by 1 by lambda 2, guys. Got it? So we have to take the principal quantum numbers, not the excited state numbers, or else we'll get a wrong answer. Okay, RR will get cancelled. So 1 by 9, 4 square is 16. Whole thing divided by 1 by 4, 3 square is 9. So this will become, therefore, lambda 2 by lambda 1 is 16 minus 9 by 9 multiplied by 16 by 9 minus 4 multiplied by 4 multiplied by 9. So therefore, lambda 2 by lambda 1 will be 16 minus 9, which is 7, by 9 multiplied by 16. 9 minus 4 is 5. On the top, we will have 4 multiplied by 9. Okay. So 9 cancels, 4 goes with 16 4 times, and there is 5 and there is 7. So that is lambda 2 by lambda 1. So lambda 1 by lambda 2 will be 4 5s are 20 by 7. 20 by 7 is the D option. Yes, that is perfect. So that is the answer. So whenever you do these kind of questions, be careful. Like, you cannot choose the excited state number. Choose the principal quantum numbers in this. Else you will get a different answer. Next one. Electron is colliding with a fixed hydrogen atom in its ground state. Hydrogen atom gets excited and the colliding electron loses all its energy. Thus, the hydrogen atom will emit a photon corresponding to the largest wavelength of the Balmer series. Okay, let's understand what is happening. So this is your hydrogen atom. Okay, and there is an electron over here. This is an electron. There is an electron over here. It is coming with certain speed. It collides with it, and this particular electron comes to rest. It loses all the energy. So now it gives all that energy to this hydrogen atom. So what happens is, the electron which would have been there otherwise in the first orbit inside that hydrogen now jumps to the higher orbit. Now it is jumping, it is getting excited to the higher orbit. That is what has happened. So imagine that electron is now in the excited state. Now, once it is in the excited state, it will eventually obviously come back to its ground state. And in this process, it will emit a photon. But that photon is the largest wavelength of Balmer series. Lambda max of Balmer series. Lambda max of Balmer series. This is what is happening in this particular question. Is this clear? This is before, this is after the emission of the photon. Okay. Now, the logic is as follows. If this wavelength has to be emitted, this will come from the energy difference of these two energy levels. So think about it. The energy of the photon will come from the energy difference of those orbits, which will eventually would have come from the kinetic energy of that particular electron. So the question is exactly that. What is that kinetic energy so that the wavelength of Balmer series is emitted? Energy difference of that orbit, maximum wavelength of Balmer. Guys, think about it. Lyman Balmer, and is 1, 2, 3. This is 1, 2, 3. This is where that maximum wavelength will be emitted when the energy gap is the smallest. So the transition will be from 3 to 2. Transition will be from 3 to 2. Oh, so what is the energy difference in the orbits of 3 and 2, guys? Standard values, I think you should remember now. What is the energy of the third orbit versus energy of the first orbit? Third orbit and the second orbit. Come on, my dear students. What is the energy difference? What is the energy difference? Yep. Come on, guys. Energy difference. Lyman, and then we had Balmer. Come on, guys. What is that? What is that energy difference? Consequently, the hydrogen atom may emit a photon corresponding to the largest wavelength of the Balmer series. Oh, that means, you know what? This electron in the first place should have at least jumped till the n is equal to 3. At least from the ground, it should have reached here. Only then it can emit Balmer series. Else it can't emit. Do you get it? So at this point, the energy is minus 13.6. At this particular point, this is nothing but minus 1.5 electron volt. So this energy difference between the orbits would have come from the kinetic energy of the electron. This is possible, the lambda max of Balmer, only if the ground electron reaches the third orbit. So minimum that much energy is needed for this to happen. So the energy difference will be minus 1.5 minus 13.6, which will give you how much? 13.6 minus 1.5. Yeah, it should be 12.1 electron volt. Just check this out. So if this much energy is given by the electron, the hydrogen atom will get excited and then it can emit Balmer series at least. Else it is not possible. So answer should be 12.1, I believe. Yes, it is 12.1. Beautiful question, guys. Or else some people will take the difference of energy between 3 and 2, which will be completely wrong. Which will be completely wrong. Awesome. Kirti, my name is Shreyas, Captain Shreyas. You can see me there. Yeah. Okay. Sanjay, is it clear? Yep. Is it clear, Sandy? Sorry, not Sanke. Sandy. Yeah, you had to take minimum energy to excite it to level number 3, or else we will get a wrong answer. Moving on to the next one, the ratio of the mass densities of these nuclei. Guys, no matter which nucleus you take, the density is the same. So it will be 1:1. That's a standard result. Okay, so keep this in mind. Unstable nucleus breaks into two with a ratio of velocities 8:27. The ratio of the radii will be. Okay. So if one nucleus breaks into two small nucleus, one goes here, one goes here, the ratio of the speeds are 8:21. I know for a fact, since momentum is conserved, momentum is conserved, I can just say initial momentum was 0, final momentum will be m2 v2 and this will be m1 v1. So m1 v1 will be m2 v2. Therefore, v1 by v2 will be m2 by m1. Now, v1 by v2 is clearly mentioned as 8:27. So 8 by 27 is m2 by m1. But we know one more thing. the mass of the nuclei is proportional to the atomic mass number. As simple as that. So I can say 8 by 27. Oh, and atomic mass number is proportional to the radius cube, right? Is that right? A is proportional to R cube, that is standard. So 8 by 27 is R1 by R2 whole cube. So R1 by R2 will be cube root of 8, 2, cube root of 27, 3. So 2 by 3 should be, or 3 by 2 should be basically the answer. Yes, perfect. So by the way, this was M2 by M1, right? So technically, if it was M2 by M1, so this will be R2 by R1 because this is M2, this is M1. So technically, this will be R2 by R1. So R2 by R1 will be then R2 by R1 will be 2 by 3. Therefore, R1 by R2 will be 3 by 2. So that answer will be option C. That option will be answer C. Is that okay? Perfect. Let's go to the last few questions of semiconductors and logic gates actually. So as you can see, there is a battery. It's forward biasing this diode. There is a drop of 0.5 volts across the diode. And there is a current. If it is more than this, it will cause some damage. So if the diode has to operate at 5 milliamperes, how much resistance will you need? Okay. So the total voltage that you are applying is 2 volts. Out of that, 0.5 volts is dropped across this. Naturally, 1.5 volts will be dropped across the resistor. Because in the forward bias, it's mentioned 0.5 volts drop is there independent of the current. So don't bother about the current. Voltage across the resistance is current into resistance. What do you have to find? You have to find the series resistance, which will give you that 5 milliamperes of current. Okay. Voltage is 1.5. Current is 5 milliamperes. So 5 into 10 to the power minus 3 into that resistance. So guys, the resistance will be how much? Yep. 1.5 is 3 by 2. And this 5 will come below. And this 10 to the power 3 will be on the top. So 2 5s are 10, 10, 10 goes. So this will become 3 into 10 to the power 2, which is 300 ohms. 300 ohms, which is C option. Very easy peasy, lemon squeezy. When you see such big paragraphs, you might think, oh, something is wrong, something is missing. No, it is straightforward, guys. It's not difficult. Moving to the next one, which of the following Boolean expression is not correct? Boolean expression is not correct. I think the first one seems to be correct because if I have a bar dot b bar, it is actually a plus b whole bar. So if I put a bar over it, it will be a bar over here. So bar will remove that bar and it will become a plus b. So I think A option is definitely correct. I think same way this is also correct, guys. I mean, just think about it. A bar plus b bar is a dot b whole bar. So had I put a bar over here, this will be also bar. So naturally bar will cancel and it will become a dot b. So this is also correct. I think this is wrong, guys. I mean, like, think about it. 1 bar is 0. 1 bar is 0. How can 0 plus 0 be 1? This is definitely not. D option is the wrong one. Even this is correct. You can solve it. It is not that difficult. A dot B whole bar. A dot B whole bar dot A dot B whole bar. Is that why? It is. So A dot B whole bar is just like A bar plus B bar. And okay, if you have treat this like one number, treat this like another number. So this dot this dot this whole bar, this dot this whole bar will be A dot B bar, dot will become plus A bar, A dot B bar, and this bar will get divided into both places. Yep. So that is what will happen. Essentially, you have chosen each of your numbers as this, and they are dotted. So that dot will become plus, and this big bar will get distributed. So this will become A dot B plus A dot B. Yes, A dot B plus A dot B. Come on, now solve this and you will see that A dot B and A dot B is just like getting the same input, ORing it with itself. It's like, what is A dot A? Think about it. What is A dot A? Sorry, what is A plus A, like that? If you see, come on guys, what is A plus A? So if it is 0, this is 0, you will get it as 0. If this is 1, this is 1. Yep, this will be also 1. So basically, it is nothing but A. So this entire thing will be just A dot B, which is the RHS, which is nothing that but the RHS. Same number plus same number will be just that same number in Boolean algebra. Yeah. Moving on. Which of the following represents correctly the truth table of the following configuration? Okay. Look at the options and probably then figure it out. So go to let's probably go to making it 0 and 0 first. If this is 0, this is 0, A bar will be 1, this A will go over here, this will be B bar, B will go over here, 0, 1 and 0, 0, 1 and 1, 1, 0 or 1, 1. So the output should be 1 for 0, 0. Output should be 1 for 0 and 0. Just check this out. Yes, is that right? Output should be 1 for 0 and 0. Yes. So 0, 0 is 1. 0, 0 is 1. I can see it here and I can also see it over here. Now, maybe you can choose this option 0, 1. If you get it, that's it. Your job is done. So let's say 0, 1. So let's say this is 0, this is 1. This 0 will become 1. This same 0 will become 0. This 1 will go over here as 1. B's negation will become 0. 1 and 1, 1. 0 and 0, 0. 1 or 0. 1 or, this is OR gate, will be 1. So 0, 1 should give you 1. So I think this is the answer. So D option is the correct answer. Is that right, everybody? With me? Just check it out. Everyone? Awesome. Awesome. So that is the correct answer, guys. And we have reached the end of the session. We have reached the end of the session. So almost a great session with so many questions for you to practice. And let me tell you, many of the questions were really good level questions. So make sure that you are practicing these questions for sure. Even if you watch the lecture at 4x, 10x, 100x speed, but make sure you are knowing how to solve each and every question, because the April attempt do not take any chances, and especially with respect to physics. Okay, I want everybody who watched today's class to comment below, and yes, be ready for the next class tomorrow and day after. Okay, bye bye, have a great time. Hasta la vista.